how users are going to use the agents. That's where traces, observability, evals, all these things come into the mix. I think you have a notion, if not a very good idea of that already, but we still have a lot of challenges around how to make use of that data in the most efficient way. I'm stoked you're here because we're going to learn some of the answers to those questions today. I think the main sort of pattern or theme that we've seen as a team hosting this event is that agents are basically getting more capable and more autonomous every single month. It started with giving our agents open claw-like capabilities. Probably in the last 6 months or so, agents are running code in sandboxes, they're writing to file systems, we're giving them access to a web browser just in case there isn't an API available, so they can solve harder problems just like a human would. Now we're starting to take those capabilities and push them further by getting our agents to run for a longer time. And if you've heard terms like long-running agents or durability, they've become part of the zeitgeist lately as we all try and push these agents further. But the challenge doing that is that the further we push the agents, the more sort of surface area there is for something to go wrong. That could be like an error in the application layer, which we can surface through traces and evals. We need to be aware of these failure modes so that we can ideally fix them. But now we're dealing with these huge hordes of traces. It can be difficult to actually make sense of them and separate the signal from the noise. Also, as agents run longer, and we do these agent loops that can span 10 minutes, 30 minutes, hours, days in some cases, suppose the server, because anything that can go wrong will go wrong with distributed computing, suppose the server fails for any reason, or the user simply disconnects, how do we make sure that the agent is durable so that when they come back or the server resumes, they haven't wasted all those tokens and all that time that they spent running an agent loop for hours? We need to talk about these things, and that's why we're here today. And I think the only way to talk about these things in a truly productive and credible way is to relate them to real engineering stories, not just theory, which I think brings us nicely to today. Today, we have 14 tremendous speakers for you. Some you will definitely recognize, I'm sure. Others you might not know yet, but they are definitely worth your time. We've also specifically made sure to include a few EU startups to show you in this room and everybody watching online or maybe the recording some of the best the EU has to offer. You will hear the word harness come up today a few times, I'm pretty sure about that. We're also going to touch on things like payment infrastructure for agents and the new monetization models that they require. We'll touch on things like security, including auth. Software factories. Has anybody heard of software factories recently? Yeah, I can't avoid them on X, but for good reason. I've even heard of people describing a new type of engineering role called a factory engineer, which is just, I think, a bit of a leading indicator of the opportunity here. And just like a lot of agents started with coding, right, and now they're being used for general co-working agents and beyond, it's very plausible and credible that we start with software factories, but the industry evolves into other types of factories. So we're very much at the beginning here today, and as we talk about these things, we all get a chance to learn about and capitalize on them. We'll kick things off in just a minute here. I was hoping that you would indulge me for just a moment while I talk a little bit about my hopes for today. We have 14 amazing speakers, just 15 minutes each. When we have a stacked lineup like ours and some amazing speakers to choose from, as organizers, we have to decide how do we want to structure things. Do we want to do 1-hour workshops, 40-minute talks? We chose 15 minutes because we think it's going to keep things fast, energizing, fun, make sure that everybody's interests are represented. For the things you're already interested in and hoping to learn more about, I think you'll get some good insights. And I really hope that when you leave this event, you'll have some new ideas as well. Maybe things you didn't know you were interested in, or things you weren't sure that were relevant to you before. That's the advantage of having all these amazing speakers. So I think after a lot of these talks, when we go into the break, when we go into lunch, you'll have some threads to pull on. Maybe you want to look it up, but you can act on these new interests right away as you ask the speakers directly, or share what you found interesting with people in the corridor. We've all been, I'm sure, to big conferences and huge expos where the audience just kind of like disappears a little bit. If you look around, this is definitely not that. This is quite a cozy, intimate, I would say, atmosphere where we all have a chance of talking and getting to know one another. I would really hope and like that people left today having made some connections with new folks, either professionally, for collaboration opportunities, or maybe as friends as well. So when you go out for lunch, when you go out for the breaks, I'm really excited to have you all meet and get to know each other a little bit. I would also really like it, perhaps, if we broke the ice a little bit here and got to know people at our tables. This is quite a cool setup, right? Usually it's a big bunch of chairs, but we have these little tables today. So if you'll indulge me for just a moment, how about we take a moment to introduce ourselves to the person on the left? We'll let them know our name, where we're coming from, and one thing you're hoping to learn from today. For example, my name's Alex. I'm your host today. I'm based in London, and I'm really excited to learn more about the SDLC. How about you give it a try? Okay, amazing. This is exactly what I wanted. I almost can't stop you talking to one another. Okay, folks. Okie dokie. This is exactly what I was hoping for. I almost can't contain the enthusiasm right now. Okay, guys, let's kick things off properly. What do you say? I'm going to take a moment to introduce our first speakers. I love this, by the way. That went better than I could have possibly hoped for. I can't contain everyone's desire to get to know one another, so I think my hopes are going to come true today. Okay, so let me take a moment to introduce our first speakers. So whereas most people building agents, they focus and they obsess and they care so much about the product they're building, their vertical, their users, they come to know that domain intimately. Mastra is in quite a unique position as a TypeScript framework and a platform serving engineers, because we see the widespread of different use cases, different users, different challenges as they attempt to solve solutions on Mastra. So when they jump on the phone with us, or we see a pattern in like Discord queries or pull requests or questions on calls, then we know that's something that people are genuinely trying to accomplish. We get to look at the different patterns and ideally solve those problems for you in the framework. And so to talk more about the most impactful trends they've seen in the last 3 months since the last conference, and what Mastra has been building to help you, I'm very excited to introduce to the stage Mastra's founders, Shane Thomas, Abby Iyer, and Sam Bagwatz. Please give them your loudest round of applause. Let's go!
Thanks, everyone, for coming out. Stoked to be here with all of you. So it's great to be in London.
Welcome to TSAI Conf.
We're the Mastra founders. I'm Sam.
I'm Shane.
And I'm Abhi. So to start us off, we're going to rewind a little bit back to where we left off, which was last TSAI Conf. That was April 9th. It was in San Francisco. And since then, Mastra has doubled our weekly downloads. We were at 600,000 then. We're at 1.2 million weekly downloads today. Last conference, we launched the Mastra platform, which is Mastra Studio and Mastra Server. Mastra as a framework gives developers primitives to build agents. And Mastra as a platform gives teams a place to deploy them and observe them.
And since we launched the platform, thousands of people have deployed and observed their agents. In 3 months, we've had over 71,000 CPU hours and over 30,000 deploys. But we've also hardened the platform with automatic deployments, managed databases, sandboxes, file systems, environments, and multiple deployment regions.
Today, Mastra is running in production across the Fortune 500, scaled startups, as well as AI-native companies.
Agents browse the web, they edit code, they operate inside sandboxes, they even talk to you in Slack. But these agents might run for an hour, or maybe even come back and talk to them again tomorrow. So it's not chat completion anymore. It's a different runtime. And so the question for us became, what primitives does an agent need in that environment when it's not just a request-response cycle?
These questions kicked off a deep exploration in the last 3 months. And we've kind of figured this thing out as, we call it LRA, long-running agents. If you follow us on socials, you know that we make moves, and we've been doing a feature release pretty much every day, and all of those are part of this LRA initiative. Long-running agents have changed the game for Mastra. It really has brought a new agentic primitive to the framework. And the biggest thing about long-running agents is they're addressable, durable, operable, and capable.
Let's start, we're going to go over all 4 of those, but let's start with addressable. In June, we shipped agent signals. With agent signals, you can steer long-running agents. You can wake sleeping agents. You can connect multiple clients to one stream. You can also update state without invalidating the prompt cache. On top of that, we added webhook providers. That means GitHub, Slack, Stripe, or your own system can route a message or an event to the right thread. We also added schedules for recurring work. What this all means when you put it together is that addressable agents aren't just waiting behind a chat box. They're stateful participants in an event-driven system.
Now, durable. So first, we ship background tasks. So your agents can respond before, during, or after long-running tool calls without blocking the agent loop. And then we shipped agent goals.
That wasn't one of them.
Wait, is that my coding agent just finished?
The fire alarm is about to be tested.
This means the conference has started. This is
Excellent.
alert. Everyone's getting excited.
First it was Alex getting everyone to talk to each other, and now it's the fire alarm. We just got something to keep everyone.
And we were given a hint that the fire alarm would come at roughly this time. So.
That's my chime on my agent is done.
We run this one jobs complete.
And to be clear, this is just a test. We're
Attention, please. Attention, please. The fire alarm test is now complete.
I hope
Thank you.
We're all still alive.
So agent goal complete. If you're watching online and you didn't hear, there was a fire alarm in the building. We knew it was going to happen. We didn't know exactly what time, but
Here we go.
I guess it was right on time. So in June, after agent goals, we also shipped durable agents, which can survive client disconnects, browser refreshes, network blips. You can run multiple requests in parallel, watch them, or leave them in flight and then come back later.
Let's talk operable. In January, we released Monster Code, which is our version of our coding agent that we run locally over Codex or Claude Code. Remember from last time, friends don't let friends run compaction. In June, we pulled out the pieces of Monster Code into a class called the Agent Controller. Do you want to manage thread lifecycles? The Agent Controller can do all of that. Want to spawn sub-agents? Well, you can even fork a sub-agent so you don't have to bust your prompt cache. Want to do multi-turns? Duh. We all do. And do you want to have human in the loop? The Agent Controller can ask you questions, submit plans, make tasks. The thing I love about this primitive is it's so easy to compose it to build your own coding companion.
Last thing, capable. Long-running agents are capable. They act, right? In May, we added a bunch of stuff. We added browser support. We added channels for Slack, Discord, and Telegram. We added remote file systems. We added task lists. We added first-class skills, and we added support for Claude Code, Codex, and Cursor subagents. When you kind of put them all together, we call this family of capabilities the Claude primitives, because what they do is they let an agent sort of reach into the world. When you put it all together, again, addressable, durable, operable, capable. When you put these all together, you get our definition of a long-running agent. It means that people and systems can be in one sort of shared loop. It means that a job can survive disconnects and restarts. It means you can watch, you can steer, you can approve, you can recover. It means you have the environment and you have the integrations that you need to get the job done.
Long runs generate more traces, though. And I don't know if you're like me. I don't want to read 100 traces, let alone thousands. Because as a human, it's just hard to parse that much data. And so that's why today we're very excited to announce Trace Intelligence in beta. Woo. Yeah. We're waiting for that. Thank you. But teams will spend weeks or months reviewing traces, and then you turn those traces into agent fixes, right? Prompt improvements, context improvements, tool description improvements. But Trace Intelligence will group traces into clusters, so you can identify common goals, behaviors, sentiments, and outcomes across mini runs. So you're analyzing clusters, not individual traces. It's built into observability on the Master platform.
Trace Intelligence is our second step towards this concept of agent learning. The full agent accuracy loop looks kind of like this. You collect traces, you review them, you create data sets, you create experiments to propose fixes to your agent, and then you ship those fixes to prod. Well, back in March, we shipped data sets and experiments, and now we have Trace Intelligence, which allow you to review your trace selection and start the next phase of the process.
As you might suspect, after this, we're working on automating the whole experiment flow by generating proposed fixes. When you automate the entire agent learning loop within Mastra, it will cut down weeks of work to days. So we've talked about this kind of learning loop. We've talked about long-running agents. But the next problem that we're going to talk about is organizational. And it means that every team has automation ideas. But engineering cannot become the bottleneck for a company to AIify itself, especially not in sort of most of organizations. The question that a lot of people are asking is, how do you let everybody build while the developers keep control of the primitives? That's why in May we launched Agent Builder. Agent Builder is a composable agent studio. It means that developers can register the tools, the workflows, the models, the memory that other people in the organization are allowed to use.
And then product, operations, and other teammates can assemble those primitives into agents and share them across the team. The result is still code and stored master configuration. So now you take long-running agents, the claw primitives, the governance, the shared UI, and then you can point the whole thing at one of the most exciting problems for agents, software development.
Today, we are announcing Mastra Factory in alpha. It's a launchable Mastra project that gives you a system of agents that can take an issue all the way into production. It has specialized agents for triaging, for writing code, validating it, releasing changes, updating docs, and monitoring prod. So AKA that SDLC that we're all talking about. Mastra Factory connects to GitHub, Linear, and we'll have more integrations coming soon. As an issue comes in, you can start the factory and watch the agent work. There are multiple approaches to software factories, and you'll probably see a bunch on X and probably from a lot of authors coming soon. The way we kind of approached it is staged automation, where work flows from one stage and has life cycles. But we also want to support fully goal-driven development, so that will also be like an autonomous feature as well.
The teams that win don't just have one genius idea. The teams that win ship day in and day out. They build systems that let them do that. And today, you can build that system on Mastra. You can install Mastra Factory, connect the tools your team already uses, and make it your own.
It's a lot of launches, which it's us. You might expect that. But I want to sort of pull back from the launches, and I want to bring this back to our journey. Mostra launched in October of 2024, and so much has changed since then. We built Mostra for the builders. We built it TypeScript first, but not just for one platform or one model provider. We built it for every model and every platform. We built Mostra fully open, now, always, and forever.
Mostra has the whole agent lifecycle. You can build your agent, you can observe it, and now you can improve it.
And Mostra started as an agent framework, and we shipped long-running agents. We became a harness framework. Now, Mostra is a factory framework. And we started targeted towards developers. But today, Mostra is also for agents. It's for your teammates. Mostra's for everyone.
When you put it all together, Mostra is the most capable agentic architecture today. If you're here building in TypeScript, we hope that it is, or it will be, part of your journey. Whether you're building agents, harnesses, or factories, you can get started with npm create Mostra.
The talks you'll hear today are from builders all over the stack, and we're so happy for them to be here to share their knowledge with all of you. Today is about giving you tools, giving you guidance, and I guess a lot of interruptions talking to each other. So please enjoy the conference. Peace.
Peace.
Thank you.
This was fun. Amazing. Okay, folks, we've got a lot of talks to get through today, so we're going to keep things rolling. Up next, we have Rachel Lee Neighbors from Arise talking about how evals are the new TDD. Rachel has worked at some companies I'm sure you recognize, like Microsoft, AWS. I first learned about Rachel when they were a core member of the React team at Meta. They've contributed to browser specs. I followed Rachel's work for a while, and everything they do is to help us build better things, to help us understand better. They're working right now doing developer experience at Arise. And all their credentials aside, Rachel is just such a tremendous communicator, and this kind of presenter that pulls you in. I can't think of anyone better to follow the opening remarks. Please join me in introducing Rachel Lee Neighbors.
Oh my God, that was such an amazing intro. I feel like I wasted an entire slide in my deck. Good morning, everyone. How are you doing today? Yes, that's what we like to hear. Hold on. I can do this. I just was demoing last night. How many of you are in London just for this conference? Oh, you came all this way from Mastra. Oh, that is awesome. Okay. All right, serious face. Okay, hello. Has this ever happened to you? Your agent is working perfectly in production, or so it seems. The types, they pass. The demo, it works. You've shipped it. But hold up. Look closely. What is that? All is not well. The agent has recovered, but there's a silent failure that's happening. And if you blink, you might miss it. We actually solved this exact problem for regular code about 20 years ago. We called it test-driven development, or TDD. But agents don't work quite the same way as code. They're non-deterministic, et cetera. Agents don't have tests. They have evals. And for agents, we need EDD, or eval-driven development, the third member of Ed, and Eddie. Yes, I am Rachel Lee Neighbors. You might remember me from such awesome places as the MDN web docs and React's documentation. Any React people in the house? Hello, oh my gosh. And TypeScript's my community. I'm working with a bunch of Python engineers, but I still very much love to work in TypeScript. I love the tooling story that comes with TypeScript. I truly do believe it's got one of the best tooling stories in the industry. And today I work with Arise's Phoenix team. Arise Phoenix is written in Python, but it has TypeScript SDKs, which we'll be using in this example. Phoenix is an open source platform for agent development and evaluation. How many people here are familiar with test-driven development? Oh, geez. How many of you have agents or LLMs in production right now? Very nice. And how many of you have evals set up? Okay, we have some work to do. And how many of you don't have LLMs or agents in production, but it's going to happen? You're here to make that happen today. Yeah, awesome, love it. Okay, well, then this is the talk for you. We have a shared vocabulary of concepts. For all of you who remember, who have used test-driven development and are curious about evals, I'm going to give you a little one-to-one here. Unit tests, that's just an eval. When you think unit tests, just think eval. Test suites. We would have reams and reams of test suites in test-driven development. With evals, we have what's called a golden data set. It's a set of inputs and outputs that you've curated, and you want to make sure that every time an agent or an LLM receives a certain input, it's going to give a certain output. A text fixture is called a trace, and assertion is an evaluator. And instead of passing and failing, we use score thresholds because non-determinism, it's not always going to pass in some circumstances. You're just trying to get like over the 85% hump. Instead of CI gates, we have regression evals. That's to make sure you don't fall backwards. All right, okay, I'm going to pause on that one while everyone takes photos. We will be making the slides available later too. I know this is fun stuff here. Okay. So let's go back to this silent failure, where we can see that the agent just said, let me find the right table to search from. Well, that's kind of, you don't want people to see that. That implies that the agent doesn't know where it's searching from. Let's go dive into the back here. First off, you can't test what you can't see. Thankfully, agents and LLMs are inherently observable. They leave a loggable record of every step they take. If you've ever looked at the logs of your ChatGPT conversations, there's the user input, the LLM's output, back and forth, and you continue to pass them back and forth. You just need to capture those logs. This is, you need to implement observability, as we like to say. These logs are called spans. They're a recorded unit of work that your agent did. It includes an input, output, timing, errors. It's nice. You get enough of these, you can mine them for gold. Now, I'll be using Phoenix for the demos today, obviously. But you have so many options for implementing observability, there's really no reason not to. Phoenix is small and it's open source, but if you're working at a big burly enterprise that needs RBAC and all that stuff, you can use Arise AX, or maybe you could use a competitor like Braintrust. Even Mastra ships with something called Scorers today. There's no reason not to turn this on and start gathering those logs, because then one day you're going to have a failure, but you're going to have all the logs for where it happened. All right, set it up today. Collecting those traces is key. A trace, that's just the full call stack for one request. Let's take a look. So you can think of like a trace as like a collection of spans to accomplish something. Here's what's going on behind the scenes at the store. And you can see we've got a collection of different traces there. I've sorted them by errors and went into the spans. So this here is one collection of traces, and these are, each individual row is a span. If you go over here on this one failing span, it's got a little exclamation mark there, it's logged that there's an exception from the tool it was calling, no such table products. This agent is trying to write its own SQL queries, but it doesn't know what the shape of the database is, so it's guessing. And if you look, and I'm gonna make you play that again. No, not that way, the other way. Yes, like that. But if you take a close look, that one little issue, when you go in and you take a look at all of the different spans inside this trace, this tool call failing triggered another tool call to go and query the entire database, and another tool call after that. So one failed tool call meant that we ended up doing 3 round trips to Claude Sonnet instead of just 1. This is the kind of, it looks like it works, but it didn't work failure that slowly eats up all your inference budget and gives your users a terrible experience. Agents are smart, but they're still expensive. That's not one of the catastrophic failures either. I'm giving you an easy example today. So once you find what's breaking, you want to save all those broken error logs into a data set. Now the data set is your test suite. Well, you can think of it as one. It's a curated collection of examples, each one an input, optionally including the expected output. And you run your agents against it about every time you change something. There are only 3 things you can change: user inputs, the model, and the prompt. I guess you could change the harness too. But anytime you change the infrastructure, you want to rerun your golden data set. So we take these broken spans and we save them as a data set. I'm just going to call it failure. There you go, and boom. Now you go check out that wonderful data set, and there they all are. You got your inputs, no real expected output, but I did include some metadata there. And that's not so hard. And the good news about testing agents is you don't have to imagine all the ways they fail. If you've ever stayed up late at night going, oh my God, I thought of another edge case. Hold on, let me go add an assertion. With agents, we learn from failure. We harvest the error logs and turn them into that golden data set. You can't predict all the ways in which a system will fail, but you monitor it. It becomes a part of your weekly practice. There's actually a really good article on the Phoenix docs in the cookbooks called Finding High Signal Traces, about the practice of going through your evals once a week and looking for the errors and harvesting the ones that really make the difference in the long run. So you'll keep acquiring these failures as a golden data set that you can use as part of your eval suite. This is important, especially as you introduce new harnesses, models, and tools. So next up, we're going to need an evaluator. Evaluators, they validate the outputs. There are 2 kinds of evaluators. You could argue that humans are an additional kind, and I've heard of agent as judge, but it boils down to this. You want to check to see when I give my agent this particular command, does it return this particular output or something close to it, something acceptable? And if it's something like, I don't know, you want to get like properly formed SQL queries out of an agent, that's very easy to validate with code. You can simply run the SQL query, or you can look at the SQL database and see if it's the right shape. So code-based evaluators are cheap, they're fast, they're easy, they're practically free compared to LLM as judge. This is where you take the output and you say, hey, Claude Opus, it's always a bigger model, and usually one from someone else. If you're using like ChatGPT as your agent, you probably want like Gemini or Claude as a judge of its outputs, because I can tell you, they do tend to agree with people who come from their own family a little too much. They favor their younger sisters. So anyway, LLMs as judge come in where judgment would be required. It's a little fuzzy, like, was this answer helpful? Did the respondent seem frustrated? Were you able to stay on topic? Is the tone correct? These are things that are much harder to regex. In this case, I made a programmatic evaluator to make sure that the SQL queries match the shape of the database. And I wrote it in TypeScript. It's actually probably much more complicated than it needs to be. I'll be honest, I let Pixie, the little agent down here that Phoenix ships with, I was like, Pixie, just make me an evaluator for this, please. And it did. It was very nice. I am a lazy coder, but I'm not a lazy tester. Now, the next, the fun step here, this is the part I like, is the experiment. You got to test. You found a way to check that the outputs are correct, but now how do you get the outputs to be correct? Well, if you saw the original, you're thinking, well, maybe you could just give the agent the shape of the database, or you could, also make it a tool for accessing the database instead of letting it write random SQL queries left and right. I'm sure none of us have ever done that before. There are a number of different ways, and you can set them all up inside an observability platform like this. Now, you can modify the 3 variables. You can modify the prompt. That includes the system prompt. That could be a prompt that's actually being sent to the agent with each user's message. You could change the models. Some models are just smarter than others. In this case, I don't think you're going to get a better result with a different model. They're all going to pick the wrong table because you didn't pick like a non-deterministically appropriate name for it. And you can change the input, although this is less possible when you're dealing with user-generated inputs. You can't really control what users are going to say. They say the darndest things. So this is how you run an experiment. I chose to update the system prompt. I just included the shape of the database in the system prompt, and you can see them running against each other here. And this one, look at that, average 1, all green. Over here, the original, zeroed out. So each time that was running, it was getting 3 calls instead of 1, and now with the updated prompt, it'll knock it out of the park, single shot every time. Whew. Same model, same snapshotted use cases, same evaluator. Old prompt versus new prompt wins, let's put it into production. Testing is great. It's still rather contrived. We're isolating all those variables and putting them into a little terrarium together. We try to make it look like the real system, but let's be honest, nothing beats introducing it into the complex system that is production. You want to make sure that you're verifying that the agent works within its natural environment, of course. And here it is actually working. What would be a great toy for a toddler? It does not bork out and have to go and query the database a bunch of times to figure it out. Good job. Thank you, little agent. And if you go and you check the traces, look at that. So much shorter. We like it. That's probably saving us like 15 cents a run. Whew. All right. And step 0 is repeat. It's the cycle of eval-driven design. You don't do this once. You do it over and over again. You find what's breaking. You take the traces, you add them to that golden data set, and you make them a part of your regression evals. These, they're how you keep your CTO from blowing away your agentic experience by accident. That has happened to some founders I know. I was like, did you not have regression evals before he went in and changed the model and the prompt and the harness? No, we didn't have that. And it's like, well, that's why all of your customers are calling you very upset right now. If you are a CTO, this is how to keep your job. All right, but the neat thing is about this technique that I just showed you is that you can use it to evaluate more than just prompts. I used it to actually get rid of Claude Sonnet entirely from something that I build on the side. Once in production, this would have cost me about $1 per user per week, but using test-driven development, using evals, I was actually able to switch over to a local model and shave a full 1.5 seconds off the latency. So it was a win for me because I completely externalized the inference cost to the user, and also a win for the user because they don't have the latency anymore. And honestly, Claude Sonnet's this was probably beneath it. All right, the cycle of evals. The cycle of evals. You collect traces. You take snapshots of the ones that fail. You evaluate them to figure out what you'd need to see for them to be not failing. You experiment, try out different prompts, maybe different models, even different inputs, and then you verify, and then you repeat. If you'd like to talk more about evals and developing with them, I'll be here all day. You can check out Phoenix and her bigger sister AX at the following QR codes. If you do one thing today, I ask you that you turn on observability and you start collecting traces. If you're using agents in production, do it today. Phoenix is free and open source. Just instrument it this afternoon. In 1 week, you can start building your golden data set. You can even use those traces with a different product if you like. But what matters is that you start tracing now. Thank you very much. I look forward to seeing you at the rest of the conference.
Thank you so much, Rachel.
Real pleasure.
Okay, folks, up next we have Raphael Titsworth-Moran from DFANG talking about deploying your agents where your customers actually want them. Give it up for Raphael. just for a moment, I think I'll give you guys a little behind the scenes here. We have like a little monitor backstage that helps you see when things are happening, but I think it has a tiny bit of lag, and you just experienced that lag. Nobody likes latency. I think Raphael's here now, so let's give it up.
Hey folks. All right, here's the clicker. I'm Raph from DFANG, and today I'm going to be talking about deploying AI agents where your customers actually want them. But we actually adapted this a little bit, and it's going to be about maybe a different kind of agent than you might expect. So DFANG has been working for a few years now on making it easier to deploy to the cloud. We initially started by building a tool that's a command line tool that makes it easy to go from a Docker Compose application to AWS, GCP, Azure. We help you provision managed databases, managed inference, and a bunch of other cool stuff. That tool is now actually open source. Very cool. You can go check it out and do what you want with it. But over time, we realized that a lot of the value that we provided to our customers lay in being able to deploy into their enterprise customer cloud accounts. So being able to go from Docker Compose to different cloud providers was useful for people who might have different customers who use different clouds. And so we started to shift and provide some tooling around that to manage that relationship between your deployment pipeline and your customer's cloud account. Now, with the way things have been changing with AI tooling, we started to ask ourselves a few questions about what does the future look like of deployment with the way AI tools are evolving. And originally, we were thinking about things the way we kind of traditionally think about them, which is you integrate chat systems into your product. There's information extraction or semantic search. There's all of these things that we kind of think of, that we imagine with AI tools. On the other side, as a developer, you might be using a coding agent to build stuff yourself before you go and deploy it. But we decided it might be kind of neat, since we're building deployment tools, to see if we can integrate AI into that deployment process as an integrated component of your deployments. So actually have the product be adaptable to the user in production. Oh, that's looking a bit weird. I don't know what's going on there. It's supposed to show you the pipeline, essentially like the user experience that we want to provide. So we've built a sample, a sort of demo application that is available with all of our DFANG samples, and you can go ahead and deploy it to AWS, GCP, or Azure. And the experience that we want to provide, that we're experimenting with, is this idea where a user at Enterprise X, so you've deployed your product into your customer's cloud account. And those users, they're submitting enterprise-grade to-dos, and they want to do something a little different. So they submit a to-do. They're like, well, I don't know. I want a due date, or maybe I want to add a description. Maybe the statuses don't match what I want. Maybe I want to view these things as a Kanban, or I want to view cards. Maybe relationships between them. Now, traditionally, that means they submit feedback to you as a developer. You decide how you're going to prioritize this. Does it work for all of our customers? Does it make sense? In this case, our experiment is that they provide that feedback into a system in this production deployment. And the admins who manage that deployment can access a board where they see all of this user feedback. And we integrate a Mastra agent into an environment that's bundled with the deployment. So now your production deployment has an environment built into it where an admin can see what's missing from the sales team's to-do list. And they can say, yeah, that makes sense. We're going to bundle all of this feedback, and we're going to submit it to our master agent. And we can see it live. So there's a sandboxed environment where these agents produce changes, and the admins can see what's going on. They can approve it, and they can ship it. So what does that actually look like? Like I said, you need an environment that is bundled with production when you deploy, that has the code that's going to run. So we have that agent with a working copy of the Git repository and all of the everything that it needs to go ahead and make changes to the application and run preview, or let the admins preview it. So yeah, basically we have a Git repository bundled into a service. It gets deployed. The admins interact with it with this dashboard. The agent makes the edits, and they can decide what should be shipped. Man, another one. All right. So there's a thing that I find really cool. Like when you think about doing this kind of work, normally right now, like my instinct might originally have been, well, let's just ship a coding agent. Like just bundle some coding agent somewhere and let it rip. But I think there's something really neat with using a framework like Mastra, because you get a lot more control. So we've been exploring like how you can use the tool to, for example, disallow access to certain files, or maybe guide the agent in a different direction. And basically give that admin, the user who's going to decide what actually goes to prod, a lot more confidence in what the agent is producing. Yeah, so some of the tools we've been poking around at is, for example, making sure that authorization stuff can't be touched. That the admin gets a full view of what the agent is producing, and that we can adapt that to the particular use case, and that you have maybe an adversarial review agent that goes in a loop, and you can have that nice back and forth that we might do as developers, but you can choose to bundle that in whatever way you as a developer want your end user to have as an experience in their production environment. To me, this is unfortunately a bit of a wacky slide right now, but I think this is the magic. Like, to me, this is the thing I'm most excited about, which is that you can encode your understanding of a complex system as a developer into a feedback loop that takes into account the needs of your customers, so that you're not just building an app that goes out and is useful for 1,000 different customers. Instead, you're building a baseline that every customer can install into their environment, and they can adapt to their specific needs with some confidence that it's not going to break, because you can build these custom agents that adapt to the specific use case. There's another thing that I find pretty fun with this architecture, which is that defang is a deployment tool. And there's a bit of an Ouroboros thing going on here, which is that you start your deployment by kicking it off like a traditional deployment with defang in your whatever deployment pipeline you've architected. Defang does defang compose up. It goes to AWS, GCP, Azure, whichever cloud account you want to install it into. But then it also gets bundled into this environment. So the agent makes the edits. We bundle defang in there. We set up the necessary permissions for defang to run a deployment from within the service that it was deployed into. There is a step where you still need to authenticate. So as an admin, you have to have access to a DFANG account, and you authorize it. And then now it'll kick off a deployment, and it'll eat itself. So everything, the way DFANG works, the DFANG CLI works, is it bundles your build context, uploads it to your cloud account, and then kicks off a build process and provisions all of your services. In this case, that service is sort of re-provisioning itself. So that Git repository that we were talking about earlier, it's a little bit like tagging your Git repo, like adding a tag by doing a deployment, which is, I don't know, kind of neat. And that's how you get everything into that cloud account recursively. This is kind of the full diagram, not of the architecture, but the user experience. You've got these two different flows. The user interacts with the app. They decide, I don't like this button. I think there's an option missing. I need dates that aren't visible. Then they submit that feedback. The admin can read it from this different environment. They can make those edits using the agent, and then you use DFANG to go ahead and run the deployment. Yeah, basically, what I want you to take away from this is I think the future of deploying applications to your customers' cloud accounts is making them adaptable. We can build a future where every environment that you deploy actually serves not only generally like the purpose of a use case, but that it adapts to every single customer's needs with boundaries, with an understanding that it's going to be safe. So if you think that's interesting, you can scan that QR code and shoot us a message, and we'll help you figure that out. Cool.
Nice job, Raphael. Thanks, man. Cool. So next up, we have Tiffany Lozensky from a startup called Pallet, which is based in Copenhagen in Denmark. I love telling people about Copenhagen and Denmark because I was always surprised at how many hard-hitting tech startups came out of Denmark. For example, Unity, Zendesk, Just Eat, Sitecore, Trustpilot, Joe and the Juice as well. And maybe Pallet will be among some of these legendary names, where Tiffany is a founding product engineer. They're here to talk about what they've learned shipping FGA, fine-grained authentication, into production. Please give it up for Tiffany Lozensky.
Thank you. Hello, everyone. I am Tiffany Lozensky, a founding product engineer at Pallet. And I previously worked at Atlassian on enterprise-grade security features as well. And I'm really excited to talk today about what I learned shipping fine-grained authorization for agents in production. And we're going to be going over real stuff. There's no theory here. This is all real errors, real things we encountered. So yeah. So first, a little bit more of a background about Pallet. So at Pallet, we're building AI context for non-engineers. We have a Pallet desktop application that is geared towards GTM ops founders, anyone that's not necessarily working in a code base, that doesn't need to know anything about Git, doesn't need to know how to use a terminal, anything like that. A little bit of inspiration from something like Conductor or Superset, but again, targeted for a completely different audience. And under the hood, it runs on Mastra, and you can choose if you want to use Cloud Code, Codex, Gemini, a local model. And we have a context layer as well, which of course integrates into the Pallet desktop application. But you can also access it through our MCP server. We have the website experience as well. And so for us, authorization was something very important to be able to make this all come to life in a safe manner and for customers to trust us. Customers all the time ask for all the nitty gritty of exactly how we're keeping their data safe, especially in this multiplayer agent environment. So you might be wondering, why are we going over fine-grained authorization and not RBAC, or role-based access control, which you might be familiar with. So role-based access control, it might answer the question, like, can this role do this action? So is Alice an admin? Yes. Okay, so Alice then has access to do things for these different teams. But fine-grained authorization poses a different question. So it's more along the lines of, does this person have the proper permissions to do this? And so you can scope the permissions from a role, but it's a little bit differently. So you could ask, okay, is Alice an admin of team A? Or does Alice have the permission to perform this managed workflow for team A? So more granular. And for us, moving into the agents world, the whole problem with role expansion becomes even bigger of a problem, because we might not just want to have different sets of permissions for different types of people, but we also might want to have agents having a completely set of permissions, sometimes one-to-one with the human, but sometimes completely separate from the human. And so FGA gives us more customization there. So we'll be focused on FGA from here on out. At Palette, we're using one model FGA across every single surface of our application. For the REST API, which is where we first implemented our FGA layer, we are using WorkOS for all of this. And for our agent layer and MCP server, that's where I'll be focusing this presentation. We implemented that there as well. So we have one FGA model everywhere. We have 3 resource types. And then on top of all of this, we also have tenant isolation, which is the second layer of defense. We're using Postgres row-level security. And so if an agent tries to query something for a different organization, we'll return an empty set. It's completely fail, close, and defense in depth. And this became important in our strategy as well. Yeah, so that's a little overview right there. So what this looks like, essentially, like I said, we have 3 different types. We have organization, team, and user. We right now have 6 roles, so we're working on expanding and adding agent roles as well. And we have 23 different permissions, so I just have a selection of permissions here. And these are all namespaced by resource. And then using WorkOS FGA, we're able to bubble the permissions down and have inheritance of permissions when we want it. But when we don't want it, like if we don't want an org admin to have all the permissions for our private team, then we don't need to filter those down as well. And when we started off rechecking an organization membership ID, we have since evolved from that, because not everything is based on a user in an agent's world. And everything is very scoped. There is no global permission that anyone would have ever, because when you're dealing with very sensitive data, it doesn't make sense to do it that way. So how did we put this all behind our agents? So we worked very closely with Mastra this year to develop the Mastra FGA WorkOS framework that you can use. And this is kind of how the setup looks up on the application side. So for us, we set up the Mastra FGA WorkOS WorkOS setup. And we mapped our resources, so we have our agents, workflows, and tools. We decided to have those be at the team scope. And then for threads and memory, we decided to have those be at the user scope. And this can be fully customized for your application. And just to set it up with Mastra, so we already had authentication, which we're already also using WorkOS for, and then we just set up FGA. And then so it'll wire for every agent, tool, or memory call, all the authorization will then flow through automatically, making it a lot simpler. So I ended up doing a lot of contribution to Mastra for this. But I think for a future user using this system, hopefully you don't have to think about all the nitty-gritty and behind the scenes. So now moving forward to what are some of the issues we encountered when we were working on this. So initially, FGA expected a human, and we ended up building a system actor approach. So one of our cases we had, so we have a lot of workflows. One of them is a context pages workflow, and it's essentially a cron job that runs every Saturday. And it'll generate a context. Did I just hit next? Okay. I see. So I don't know what's happening. But so it'll generate context for an org, for a team, and for a member. So that's custom at different levels. And for the org level and the team level, there's no particular person. So you might have like things that are bubbling up from a lot of different users, because one of the concepts of Palette is kind of a multiplayer approach, working with your teams, sharing context. And then, so after that, we prepare things. We have different agents that prepare things. We might have like a Notion agent that is like looking at the Notion-related signals we're getting in, a Slack agent. And we might want to have them have different permissions. And then we generate the final page with a large language model, and then we save the context. So what we ended up doing was indicating what is the kind of actor. So it could be like a system actor in this case. And then what is the name of the source workflow? And then based on the name of the source workflow, you can map permissions that way. So you can have workflows potentially have different set of permissions, and then the agents within the workflow, if you have a lot of agents, they can also have different sets of permissions. This became super important to not have a bypass. There is an option for a membership bypass if that doesn't make sense for your use case, but the idea is to require an actor to have safety across the way. And even if you do the membership bypass, everything is fully audited, and you can see, okay, which workflow did this, like where is this coming from, why is this happening this way, and then that helps determine like why you might have gotten an authorization error of 403, or why something went through that shouldn't have, so that you can debug easier. And super important too, the tenant guard stays on, so all our data is protected with tenant isolation with row-level security in WorkOS, and that helps in scenarios where maybe something wasn't set up exactly how you liked. And this is because this was like throughout the build phase of building out the Master FGA experience. Yeah. So now moving forward to the MCP surface. So we hit some different edge cases while we were building this out that we needed to resolve. So the first two are a little bit similar. So for the first one, we had a failed check that threw globally, and then every tool went dark at once. But Master was able to merge my fix within 48 hours. So it's like a nice example of that collaboration. And then the second one was that tool scopes initially weren't independent of each other. And we realized we needed to scope everything per tool and not per session. So even across a session, you can have different sets of permissions along the way, and we worked on that fix together. And the last one was more serious. So we had a cross-tenant leak through a shared MCP result cache. So initially, we had these page titles that came up in our MCP tool that you might see in the Palette desktop app or even Cloud desktop app, however you were using Palette. And we changed the names to be custom based on that particular customer. And then you can click through and see that information there. And when we changed that, all of a sudden there was a leak, and you can see some for another team. We fixed it the same day. So everything's okay. But what helped us a lot here was, even though we had that error, tenant isolation blocked anything really bad from actually happening, because even though the page title was leaked, when you clicked into the page, it was still fully stopped. The database, which is independent of the authorization layer, knew this is a different organization than we were looking at before. We're going to return nothing here. So something super important that I want everyone to take away is that agents change the threat model. So you might have heard of prompt injection, and I just, for the sake of this conversation, I'm going to assume that that's never going to be fully solved. So there's always a possibility some bad instruction can slip through into an agent, especially for us at Palette. We're getting data from Slack, Notion, like all different like long form content. And you never know, like someone might mention another customer. That customer could also be our customer. We want to make sure there's no bleed through. whatsoever. So having like a lot of different safety checks is super important. Because a hijacked agent will always try to do more than it should. So another one is tool access. So for a user's agent, every tool call is a permission check. So if it's hijacked, it can't exceed the user's grants. And so that's how we've set it up with Mostra. And system actors are the gap. We don't want them to bypass checks. We don't want to have like a fail open case. So that is something we worked really hard on making sure. And of course, tenant isolation is super important. So row-level security is like that final gateway, and you can have it onto your agent's database as well. It's not on like your databases at your company. The database that you have set up, like maybe through Mostra, you can also add tenant isolation on top of there, on the memory database, whatever you want, and that really helps as well. And we're working too on expanding it, not just org scoped, which we have today, but team scoped, or maybe even user scoped if you have super sensitive data. So just for fun, some numbers of the story. So we actually had a different authorization approach before we moved to WorkOS, and we used to have more resource types, so we were able to simplify that down. We have 82 models under row-level security. We had a bunch of different edge cases we found and fixed with Mostra, with most being fixed the same day. We filed 8 issues upstream with Mostra, which helped get things resolved quicker. And then I went from customer to contributor contributing 3 FGA-related pull requests. So some takeaways. So first, it's important to design authorization before your first paying customer. Hopefully, for most people, you don't have to go through all the nitty-gritty if you might want to use Mostra authorization. But it's definitely important to do it. You don't want to get a Sentry page relating to a leak like that. And background jobs and agents are first-class actors. It's important to name them and have like an idea of like what has access to what in all different cases. And every new surface is a trust boundary, like the MCP layer. It's important to design auth in. Fourth, one gate is never enough. So we found a lot of success layering authorization and tenant isolation. And I think there's even more layers you can do as well. Fifth, file your edge cases upstream. You know, whatever your company allows you to disclose, of course. We were very vulnerable working with Mostra in this experience. I mean, a lot of these bugs that I mentioned are fully public. And that really helped resolve things quicker. Now we have other people from other companies pitching in, working on this. So that was really cool. And then last, for us, like I said, we have WorkOS FGA throughout our entire application, and that simplifies things immensely. Also simplifies billing, of course. So yeah, essentially that's it. Thank you so much. My email and LinkedIn are on the slide. Nice talking to you.
Good job, Tiffany. Thank you for that. Okay, folks, we're going to take a short break right now. So you can head over to the main area where you came from. There'll be some snacks, some coffee, some drinks. We're going to reconvene in half an hour at 11:25. Feel free to find some of the speakers like Tiffany, Raphael, Rachel, ask them about their talks. You can also find folks at Mostra in the very bright, hot pink t-shirts if you have questions. I'll see you in a little bit, okay?
the city of lights. Sunshine on my mind, we're burning through the city of lights. You're the sunshine on my mind, we're burning through the city of lights.
Welcome back, everyone. I hope you enjoyed your coffee break. We've got some more talks lined up for you now before lunch. We've got 3 talks coming up. The first one is going to be from Jan Peer-Stocklemeier from Sentry. Just out of curiosity, who here has heard of or has used Sentry before? Like, everyone's hand goes up because Sentry is a legend that's been around for a while. And when we think about this kind of industry shift that's happening, some dev tools are not necessarily adapting, but Sentry is right there at the forefront, helping us navigate some of this. So I'm so excited to have Jan join us from Sentry to talk about the CLI is dead. Long live the CLI. Let's give it up.
Thank you. Got to plug this in. All right, looks good. I hope you're not getting too confused about the title, but at the end of the presentation, I promise you understand what this is about. All right, so before I get started, let's go back in time. The reason why we actually are sitting here is because one of the biggest events in history, I think, is because of the ChatGPT launch in November 2022. I mean, we're also here because of Mastra, so thanks for them that we're here. But they were founded actually later in mid-2024, followed by a lot of more hype right after, and 0.1 preview release from ChatGPT or OpenAI again. Funny enough, in November 2024, the MCP launched. There was also more hype around it, more agents are coming out, but after 1 year of the MCP being in existence, people said it was dead. Everybody claimed that the CLI is actually better than the MCP because of various reasons. We at Sentry, we have an MCP. It's called Sentry MCP. So is it actually dead now? It is actually not. So we are improving it every day further and further, and users loving it, and they are adopting it on every day. So it's not really dead. Also, the MCP version 2 comes out soon, so I think end of the month, so it's far away from that. But looking at the chart on how a MCP server actually works is you have an LLM, you have a round trip to the MCP server where you have tool inputs, there's something going on in the MCP server itself, and then you have an output going back to the LLM. So it was actually designed for being used by LLMs. So now if you want to use it as a user or as a code in a program, it's kind of hard to use it. It works, but it's not actually designed for it. And this is why the CLI comes into place. And luckily, we at Sentry, we have a CLI, and it was created in 2015, so long before agents were ever existence. The features what we had at the CLI were the release management, we had source map uploads, bug information file uploads, and sending events. So everything you needed to have in order to have everything running in Sentry to work. It was set up once, and then you barely touch it because it's just uploading the source maps on build time. Of course, it didn't work with the project setup. There was no CLI, which acts as a second UI. There was also no agent integration because in 2015 there were no agents. And you couldn't use the API directly with the CLI. About the project setup, we thought about something. First, we thought about putting in a CLI, but well. So when we think about Python, how it works in Python, when we want to set it up, you have a normal code like this. The only thing you have to add is importing it from the Sentry SDK and then initialize it. So that's everything you have to do in Python. However, in JavaScript, there are different frameworks like Next.js, RegRouter, Nuxt.js, and so on. There are also different runtimes like Node.js, different browsers, Span, Dino, and so on. On top of that, because JavaScript is kind of verbose, and it needs to be shipped to the clients on the browsers, there are bundlers which helps you to minify the code. Of course, it's kind of cumbersome to add everything up to it, but once you run it and you run into an issue, you upload, or the error gets sent to Sentry, and it kind of looks like this. It's not nice to read, but the CLI actually helped you uploading the source maps to make it magically look like this, so you can read the code within Sentry itself. Sentry Wizard was actually here to help you with that. So the wizard was just a CLI, which kind of sets up another CLI, like the Sentry CLI, that goes from top to bottom and says, OK, this is what you've done, this is what the features you want to have, and you're good to go. So the project setup is now done with 2 CLIs. We had the Sentry CLI and the wizard, but we still didn't have all the features we wanted to have. And the Sentry CLI was, in 2015, built for one reason, uploading the source maps. And it was OK, and it was working really good. It's also working today really nicely. And if you're looking at the releases on the Sentry CLI, you see a lot of files. Those files are actually binaries, because it is written in Rust. The thing is, if you want to use it as a SDK within your code, you need to have some binary execution. In this case, it was fine because it was designed for that. It was only running within CI/CD pipelines or sometimes locally on your code. So it was always running. What we always wanted to have and what we strived for was to have a CLI which acts as a second UI. So if you want to debug something, you have to go to the web browser, click that, and then you find something. But it's kind of cumbersome if you want to have it as a CLI. Also, there's GitHub, which has the GH CLI. There's also 1Password with OP, and so on. We didn't have that until now. We have now the Sentry CLI, which is a different CLI than the Sentry CLI. It's called Sentry. And we've rewritten everything from Rust with a TypeScript layer on top to TypeScript alone. And there's a good reason for that, but I come to that later. So we not just rewritten everything, but we also dropped the CLI because it's way cleaner, right? So Sentry CLI is gone, and we now only have Sentry. Cool. So what kind of features do we have? So first, we rewrote the entire code base from Rust to TypeScript, so we already had feature parity on its own, but we wanted to combine now the Sentry wizard into the Sentry CLI. So now we have the Sentry init command, which helps you to initialize your code with help of an LLM, because every code base is kind of different, and it helps, so LLMs can help you with that and doing it better. The way how it works is like that. You have your code running, your Sentry CLI is also locally, and the Sentry CLI communicates now with the Sentry server and has features to the LLM. So we have a way to detect your platform. We also have a way to select the features based on the Sentry docs, so we are always up to date on this part. And there's also planning code mods and applying those code mods. So it's working, I think, a little bit better than the Sentry wizard because every code base is a little different than the other. So how it looks like is once you type in Sentry init, you come to this dashboard, you press continue, and then you come to this nice dashboard where on the top right you see the tasks and which step you are currently in. In this case, we are in a selecting features task. And on the left side, we are getting prompt which features you wanted to have. In this case, I have sessions, session replay, tracing, logs, profiling, and user feedback. If you would have now a backend service, you might not have session replay or user feedback because it's depending on which platform you are in. Cool. So now when we had that, the Sentry init goes back to the end. It verifies with, I think, an eval if everything is working correctly and gives you all the stats. So which platform are you on, which programming language, which were the docs, and so on. So you always know what is happening behind it. So now we have not just feature parity, but we also combine two CLIs into just one CLI. But our main goal was actually to have the CLI acting as a second UI. This was our main motivator, to have the Sentry CLI replacing the Sentry CLI. But how does it look like? This was kind of straightforward. We just packed all the features we had in the product into the Sentry CLI, right? So we have two colleagues over here who are doing the Sentry CLI, so thank you for putting everything from the product to the CLI. And we have that now. I think it was not that straightforward, but from the looks, it is kind of straightforward. And nowadays, everybody is using LLMs, or mostly. So we also try to focus now on the agent integration, to just have an easier way of integrating with it. How it looks like is we have the Sentry help command. The Sentry help command gives you, like any other help command, information of what commands there are inside one command. So in this case, we have the Sentry help issue, which shows you all the commands like list, events, explain, and so on. The thing is, it is human readable, but LLMs need more context. Of course, not too much context because LLMs could be quite misleading if there's too much context, but just something in between. So we added a thing called -JSON to it, which gives you a little bit more addition to it, that the LLM has enough context to figure it out. So if you scroll down, we have now the Sentry issues events with a full description, which is kind of human readable, but better for LLMs because they just love text. Cool. But there's another thing. So with Sentry CLI setup, which we run conveniently for you when you install it, it is doing, of course, all the paths, but it also inserts a skill for you. What it does is, in your coding harness, you just say, what are my last issues, and also include the most important traces, It reasons on the back. It says, OK, I'll use the Sentry CLI to fetch the recent issues and traces. Let me load the skill first. It's loading the skill. And the skill translates everything from your natural language into the CLI command. So in this case, you don't have to touch the UI ever again. You just type it in your harness what you want to have, and we translate it for you. Or actually, the LLM translates it for you. So now we actually have an agent integration baked in. Fun fact, we also have human integration, because the Sentry CLI was built by humans and agents for humans and agents. So now the last thing, how to use the Sentry API. Because sometimes the product moves fast and fast, but the Sentry CLI might not keep up with the pace. So it could happen. It's not that it will happen, but it could. For that, we, of course, have the Sentry API command. With the API command, you just have an endpoint. You make authenticated API request, and that's it. The problem now is that LLMs need context about which endpoints it got to call. So most of the times, it's fetching the docs, or it goes online, go to your product. But we actually thought about it and had the Sentry schema command. The Sentry schema command gives you all the resources there are, with the resources, counts, and methods, everything what the LLM actually needs. The LLM might not use this one, but the JSON command. So now again, if the product moves faster than the CLI, it could happen that the API is not, or the schema is not up to date. It is, because we are sharing the code with the Sentry API. The Sentry API is always up to date in the product, of course, and because if the Sentry API is updating, the CLI is getting updated as well. So at least on the schema, we are always up to date, and you never miss out on the features on the CLI itself. Nice. So now that we have it, we are kind of complete, right? So what if you want now to use the CLI in your code programmatically? Of course, that worked before, but as we said before, it was written in Rust, and it could not run on every runtime at all. So if you want to use it in a browser, yeah, bad luck. Actually, because it was written now completely in TypeScript, you can do it something like this. You just import, create Sentry SDK from Sentry, you use it, create a SDK, and use all the commands there are what you want to have. Of course, like with the Sentry API, we wanted to have an escape hatch in case we miss something. So at the very end, you see an escape hatch in order to use all the features in case we miss something. So in this case, we just run SDK run, and then -- version. So you can always use everything at any moment. And this is kind of important because we want you and LLMs to use everything at any time, point in time without you touching the UI or the web UI. So now, what is the difference between an MCP and a CLI? Should we now kill our MCP, or should we just move everything to the CLI? Well, the difference between the CLI and the MCP is they have different use cases. Of course, a lot of code is shared, in our case, between the MCP and the CLI, so we move everything into one code base. But there are different use cases. Just to name a few, there's the reduced context, which might not be true in the version 2 of the MCP, but it is so true in version 1 of the MCP. That's why there are so many blog articles out there, why the CLI is better than the MCP. But there's also the CLI is better for using it programmatically. Of course, you can do it with the MCP, but not that nicely. It can be used by humans, like you just type in Sentry help or whatever. You can also easier switch between harnesses. So Peter here, he loves to use the CLI, not just because of the context reasons, but he can switch between harnesses at any point in time. So the CLI is set up once on your shell, but the MCP needs to be set up on every MCP on its own. Of course, the MCP also has some strong arguments for it. For example, it works without a binary, so you don't need to install anything. You can also deploy it easier, and you have better control at enterprise scale, which is super nice. So we keep both, and that's it. So thank you, and now we have some time for questions, I guess.
That was terrific. Thank you.
Thank you, too. Any questions?
Yeah, we've got time for some questions. So if you raise your hand, we can run you a microphone quickly. So there's one.
I got a microphone over here.
It's okay. Yeah, we've got Leonard here helping with the mic.
Hi, thank you for the presentation. My question is the agent integration. Is it simply shipping skills with the agent, or is it any more than that?
Maybe it's just that. It's just that. So I also give the mic to Burek, who is the main responsible person.
Wait, Yara, come on up so we can get you on the camera as well. Why not?
Round of applause for Burek.
Let's go!
I was asking you the question just in case. So the question was, is it just the skills or is there anything else? Well, I mean, it's mostly the skills that we installed them. The skills are auto-generated, so they're never stale. But they're auto-generated with some human, input around them. There's like an interesting stuff in our repo, which you can see. And the other stuff we do is the --JSON and the schema thing. So those are the agent integration parts. Like the schema command is not amazing for humans, but it is built there mostly for agents. And the inspiration was the Google's Workspaces CLI, I guess, like there's the notorious one. But like the guy who wrote that had like a nice blog post, and we were like, oh, those are nice ideas, so we borrowed some of them. Yeah.
One more here from the gentleman in the white top, Leonard, just over your shoulder.
I guess my question is, do you somehow detect when you run the CLI that this command was called by an agent versus the human?
Yes, we do. But we don't change the behavior. It's only for reporting purposes.
What about if there's some commands that you want to hide from an agent?
So far, I don't think we had the need for hiding commands. But yeah, that's an interesting idea.
Okay.
So the few detection layers we have is like, it's the agent detection plus the interactive, non-interactive. So if you detect a non-interactive flow, but it doesn't have to be an agent, it can be like a CI flow, we behave differently in certain aspects, like we try to not ask you questions, etc. But like, we don't do any command hiding whatsoever. Like the behavior doesn't change. That's the main point, I guess.
Are you able to tell which agent exactly is calling it?
Most of the time, because they emit like some environment variables and stuff. So it's not like we doing some crazy stuff. They actually want to be known.
Got it. Thanks.
Maybe a question from this side of the room. Any more questions for Jan?
Or Burek?
No, in that
Just
case.
want to thank everyone, and Jan specifically. He told the story quite well. Thank you so much. Couldn't have done better.
Thank you.
Thank you. First. Okay, and a big thank you as well to Sentry for sponsoring. Sentry do an amazing job like supporting events in the community, supporting podcasts, and we're so lucky that they come here and talk and not just give a sort of light demo, but bring us some real value as well. So I really appreciate that from Jan. And up next, we have another sponsor. We have Tyler from Copilot Kit talking about AG UI. Please join me in welcoming them to the stage.
Hey guys, just give me 1 second. All right. I think that this is going to work.
I think sometimes it takes a moment.
Cool.
But we'll figure it out.
Everyone having a good time? Yeah? Nice. Awesome. So I'm going to be talking about agentic UX today. And if you're not familiar with what that is or why anyone would talk about it, you're in the right place. Specifically, I'm going to be talking about a protocol that we maintain called the AGUI protocol and how we see it redefining AI-driven user experience. First, though, I'm Tyler Slayton. I have been at Copilot Kit for about 2 years. I lead open source there. I'm from the United States. I was born and raised in North Carolina. So at Copilot Kit, we have a thesis. And the thesis is that all UI will be AI. What does that mean, though? So if we look at this chart, we have our agent in the middle. And if we think about the way that we're interacting with applications today, core applications like Figma, like Linear, like Stripe, they're becoming agentic, right? And that is our thesis, is that this is going to continue to grow, and the adoption of AI is going to be through UI. We're building all of these great agents, but how we actually ship them to users is through user interfaces, right? And if we can kind of take a step back and look at where we're at right now, we send an agent a message and we get a bunch of text back. We're kind of in a similar situation that we were in the 1980s. I wasn't alive in the 1980s, but I can certainly read a command line and know that it's a lot different than going and clicking a button, right?
Those were the really simple days, actually.
Those are the simple days, he says. Hey, maybe we're going into the complicated days. No, I'm joking. But I think that what we believe at Copilot Kit is that we're entering the kind of Mac era, the user interface era for AI. And we're really trying to enable that as a company. But first, what is Copilot Kit? Copilot Kit is the front-end stack for AI agents. We think of front-end stack as anywhere that you're building a front-end. This can be inside of Slack. This can be inside of React, Angular, mobile apps through Kotlin, Dart, wherever you're building. We build generative UI, which we'll get into. We allow you to provide human control for your agents, so collaborative interactions. And we do this at every surface. And a surface is where we do core work like Slack, but also in React if you want to embed it into an application. We created AgeUI. AgeUI, if you haven't heard of it, is the Agent User Interaction Protocol. We'll be talking a lot about that as well. And everything that we build is open source. So we are currently at 35,000 GitHub stars, 14,000 in AgeUI, and we actually have 3 million weekly installs across our packages. We also power 30 million weekly agent interactions. So this is basically one turn of an agent. So if you send a message, we facilitate 30 million of those every week. And we're used by 50% of the Fortune 500s. And if we think about UI and why all of the UI that we look at today is text-based, it's because building agentic UX is really hard. They break the traditional request and response paradigm that we've been operating on for the last 30 years of the internet, which is we send a request and we get a response in a timely manner. Agents kind of break that a little bit, right? They take a long time to do work, and so we have to re-architect our systems around this, right? Think about if you've ever built an agent that runs for more than 15 minutes and you're in a serverless environment, if you have interacted with that before. So they're long running. They also do structured and unstructured inputs and outputs. This is why they're flexible. This is partly why they're useful, but it's also one of the things that makes it hard to maintain and interact with. We also now are bringing in this notion of composition. So we'll decompose a task and send that to different sub-agents to complete that task. And we need ways to show that UI efficiently. And they can also, as we'll see, build non-deterministic UI. And how do we control that? And how do we make that a nice user experience? So that's why we built AgeUI, was actually to solve these problems. And so AgeUI is the Agent User Interaction Protocol. It's for connecting agentic front ends to our agentic backends. And we're going to be talking a lot about Mostra today, obviously, and lots of TypeScript. That's the beauty of TypeScript. Everything is going to be end-to-end TypeScript with React. But if we take a look at the protocol landscape, we just heard a great talk about MCP and where MCP is heading. MCP is for tools and context, and with some recent additions, they also now can return iframes, so you can embed whole entire applications into the places that our agents are working. A2A is basically two agents communicating to each other. So if you have a standard microservice architecture inside of a large enterprise, and you have this kind of mesh of services, A2A is to kind of facilitate that at the agent level, right? So the protocol is trying to enable that. What AgeUI is trying to do is make it so that you can take that exact same agent or any agent in that mesh and serve it at any surface. So Slack and React, WhatsApp, we have lots of different integrations. And this is a pretty big chart, but I'm going to explain it very briefly. Basically, Copilot Kit is your front end. AgeUI is what's connecting it to your back end. It's the TLDR of this entire diagram. And when we released AgeUI, it really caused an ecosystem-wide shift. We've been working a lot with some of the hyperscaler enterprises like Google and Amazon and Microsoft and Oracle to ship AgeUI at scale within their platforms. We are also adopted by many of the AI leaders in the AI space, Mostra included. And we work with a lot of consultancies to ship AgeUI into production with a lot of companies through those consultancies. So how does AgeUI work? Well, AgeUI is a set of 16 standard events. We just added 2 recently for encrypted reasoning, so 18 standard events. And they're basically for an abstraction of agents. So we created model routers like 2 years ago. That was on the rise about 2 years ago. This took all of the different model APIs and condensed them into one unified stream so that we don't have to change our business logic to change out our models. But we never actually did that for agents. Agents actually have the exact same problem, where when we're building different agents in different frameworks, now we have different streams, right? So now we have the exact same problem that model routers are solving. AGUI solves this. That's the entire purpose, is to unify these streams into kind of one output. And we can do lots of really cool things with this. But let's take a look at an example run, right? It basically boils down to just JSON data, right? That's the beauty of it, is it's really simple, and it's event-based. These events are just JSON objects, so we can port it really easily to different frameworks. So the adoption can be really easy. It's just send your events in this format, and you have adopted AGUI. So if we kind of go through these, this is the usual suspects. So we have text message that starts. It starts streaming content. We're Delta-based protocol, so that means that we'll only send the changes, so you can create efficient streaming. A tool call will start. We also have this concept of state snapshots. So I haven't actually been watching the talks, but if we've talked about memory, Mostra has fantastic memory. It's one of my favorite parts of the framework. State is effectively for memory, ways to surface the agent's memory to your users. It's not necessarily a part of the conversation, but it is a part of the conversation behind the scenes, right? So it's a nice way to surface something to a user. And if we take a look at the diagram here, I really just want to showcase, this is our agent backend. It talks AGUI out to our client. Our client exists across a bunch of different SDKs, and then that is how we actually ship across many surfaces. But the really meat of what I wanted to get to is putting this all together live with you as though we are all working towards a solution to build some agentic UX together. And what we're going to be using throughout this talk is generative UI is going to be our design space. So I want to introduce you to that design space. What is generative UI? Well, generative UI, at Copilot Kit, we kind of coined this idea that it's a spectrum. Generative UI is a way for agents to surface content to users that is not just text, right? Markdown has some ways to do tables and kind of small components, but this is true reactive, interactive UI. And to get this, we have kind of 3 notches on a spectrum and a bunch of little tiny bits that kind of fit on that spectrum. So we're going to be talking about all of these, but to introduce them, controlled generative UI is where we have a lot of control over the output of an agent, and the agent just decides what it's calling. It's not actually generating it on the fly. This is effectively calling a tool and mapping that tool to a component on the UI. Declarative UI is where we're taking it one step further, and we're composing a bunch of components together into one generation. And we'll look a little bit more into that. And if you've heard of JSON render is a great example. If you've heard of A2I is a great example of this. And then all the way at the end, we have MCP apps, which is basically a way to bring MCP apps into to bring MCP-enabled applications into embedded chat experiences, which is pretty cool. And then all the way at the end, we have open-ended generative UI, which is basically where we spin up some sandbox, we generate some UI, and we show that UI to the user progressively, which we'll see. So I want to start with our agents. There's going to be a lot of code here, so I'm just going to zoom in a little bit. But I'm going to kind of walk you through it. So I have a pretty simple agent here. I defined some incident tools. This is we're going to be building an incident triage bot. So a lot of this is I'm just making a really simple one for the sake of demonstration. These tools effectively just return, hey, there's an incident, and here's what it looks like, right? We're going to be making this pretty cool as we go along, though. I use GPT-4.1 here just for speed and cost. And then I give it some pretty simple instructions. Nothing too crazy, but this is all the Mostra that you know and love. And then I provide this is all on the front end now. Then I provide a Copilot chat component. This is basically going to be a default way to render some interaction with the user. This is all in React, but it, again, scales to any surface. And if you're wondering what Slack looks like, don't worry, I'll show you. But you'll also see right there, it says there's a runtime URL. This is basically a proxy to your agent that says, hey, I'm using AGUI. Please use this URL for AGUI. OK, so now we want to provide a component so that as the agent is triaging an incident, it can show us something about it, right? In this case, I want to see the health. We have an incident where we're no longer able to check out code from our repository. So when we do get checkout, that's no longer working. Why is what we're trying to figure out. So we're going to provide a component where it shows us the health. And just a standard component, you can see here, we're going to parse the props that are coming out of it. And then we're going to pass that to a component that I wrote, which is just standard React if you've ever written React. All right, so this is our demo. This is going to be what we're going back and forth from. It's embedded right into our presentation here. I'm going to ask it to now check out failures, or check out failures spiking, can you investigate it? And just like that, it returned that card that I just specified, right? And it's populating all that data through the tool call, which you see right here. And what's cool about this is the client is actually defining this tool, sending it through AgeUI to the master agent. And the master agent was never changed, right? So now the master agent is able to know how to render UI inside of this surface, which is really important at scale because I can do this exact same behavior, for example, BlockKit. If you're familiar with BlockKit, I can now give my agent BlockKit from the Slack channel, which I'll talk about in a second, and it's able to render all of this UI. All right, now I want to move on to declarative UI. So this is where we're going to basically generate a schema, let the agent generate a schema, and we're going to map that to some renderers. A2UI is a protocol that we helped build with Google. We own the React portion of this, and we built a lot of these SDKs, or sorry, a lot of the React SDK that you see here. So first, we're going to create a catalog. A catalog is a composition of two things. One is the actual JSON schema that I just mentioned, and two is actually going to be the renders, how we render that JSON schema. And then we just pass it into the Copilot Kit provider. If you're familiar with React, this is just a provider to provide context to an application. If we look at the catalog, who here is familiar with Zod? Any Zod lovers out there? Oh, nice. I love TypeScript AI. So I don't have to explain Zod. But we just define some Zod objects, which allows us to then pass this to the agent. Again, the agent doesn't actually have to be aware of how A2UI works. A2UI is actually transporting the ability to generate A2UI to the agent. So the client can define, hey, here's all of my A2UI. And then the agent could just say, great, I'm going to go use that, and you don't have to actually change any of your business logic. On the other side of this, we just define a renderer, right? So we define a severity banner and what it is going to generate here. And then we define what that actually looks like. So we map the schema definition to the schema renderer. And if we put all of that together, I can actually ask it to build the incident workspace. So build a workspace for this incident so that I can get more information about it. It'll take a little bit of time, which is one of the cons, actually, of declarative UI. Not too long, though. And now I have this UI. What it did here is pretty interesting, though, if we really think about it, because I didn't actually specify how to put these pieces together. I just said that these pieces exist. Please figure out how they go together. So if I ask this to do this 3 times, I might get different layouts every time, or if I slightly change my prompt, it might change a little bit, but the components will always look the same. And that's the beauty of declarative UI is you can get really a set, or you can compose subsets out of a superset of your components and compose those together. So in this case, it decided, hey, this is a severe incident. Here's why. Here's my evidence. Here's my hypotheses of why I think this is happening, which is pretty cool. And we didn't really do a whole lot here. Really, we just specified, hey, here's the data that you can generate. Here are the components that you can build. Go and build it. And I gave it a pretty fuzzy prompt here. If we saw the agent from the beginning, you can see here on the left, there's not a whole lot going on here. All these tools do. It has basically a tool for getting data from API. And so it gets the data from the API, notices that an incident is occurring, and then it's calling these components back to us. So now I want to talk about Open Generative UI. All I do is set Open Generative UI to true. And again, through the AgeUI abstraction, it's going to transport tools from the front end to the agents. And the agent's going to know how to build sandbox UI on the other side. So in this part of the demo, I want to make it super clear. I did not ask it, or I didn't specify what this component looks like. It's just going to go generate it kind of on the fly. So hopefully this looks cool. It is totally up to the agents and the intelligent model behind it to come up with something that is relevant to the user. So you can see it generate live here. This is what it came up with. What's cool here is I did ask it kind of in some of my prompting behind the scenes to give me a little button called Review Rollback. And so what that's actually going to do is render a new card where it says, hey, I want to roll this back. Are you going to let me? How do we do that, though? So if you're familiar with Mostra, Mostra has a concept of suspend and resume. The AgeUI protocol has the ability to interact with these suspend and resume type of workflows. So I'm just going to show you what that looks like. First, I create a tool. I give it a suspend and resume schema. And then inside of the execution of that tool, I just grab the resume data, and I call suspend. So at this point, when suspend happens, the agent is no longer executing, and then we will call it back with the Age UI protocol to reactivate it, basically. On the UI side, we have a hook called useInterrupt, which lets you just define, hey, when an interrupt happens, please render this UI, and here's how you resolve it. So we have this little resolution handler here to resolve that. Then I can come in here and I can improve that rollback, and it is going to resume the agent, and the agent is going to say, great, the incident is resolved, yay, awesome. Pretty cool. But I have been talking a lot about Slack, so how does this all look inside of Slack? Well, we have what we call our Channels SDK. So the Channels SDK is a superset of all the different messaging platforms that we know and love, like Slack and Teams and WhatsApp. I'm going to be focused on Slack today. One of the things I didn't show you is actually how we connect through Age UI to our surfaces. It's actually as simple as just providing a URL to the master agent. So I define an HTTP agent. This is coming from the Age UI client. I provide the URL, and voila, I have Age UI, right? Then I can create a channel through the Channels SDK. In this case, I'm going to name it Kite. Copilot Kit's logo is a kite. That's why it's called that. And so when I go into Slack and I type @kite, it's going to trigger my bot. I provide the Slack adapter with a token and app token. This is just some triage that you need to do behind the scenes. And I also provide that agent that we just defined. So the same agent that we've been using this whole time inside of Slack. I also provide it with some tools. So earlier I kind of promised, hey, I can also define the ability to render block kit. That's actually what the default Slack tools are. So we use A2UI to generate the block kit schema, and then pass that back to Slack, and voila, we get block kit. If you don't know what block kit is, it's kind of like a declarative UI language for Slack. And so it looks a little bit like this. So I took a previous execution of this, and I basically said, I'll move my cursor out of the way. I basically said, can you explain what's happening here? I just took a screenshot of that generation that we got before with A2UI, and I said, can you explain it? And Kite responded with, hey, here's what's happening, right? This is a block kit component. I just decided to render, but I can actually also say at Kite, here, let's see. Sorry, I'm trying to use a thing called Whisper Flow, but it's not starting. Anyway, so if you don't know what Whisper is great. It's a way to transcribe your voice to text. But I can ask Kite, hey, I don't actually understand this. Can you show me some UI, maybe a flowchart of what happened? And that's going to instantly trigger it through that code that I just showed you. So the agent is going to start thinking. You can see that happen right there inside of the thread. If we open it up, you'll see Slack recently shipped this really nice like agent-first experience where you'll see this nice thinking UI as it's executing. It also ships some really cool like streaming primitives. So you saw like kind of like how our chat looked like a second ago is in Slack as well. And you actually have the ability to open up full chats. You can like DM this and interact with different past conversations. You can bring it into your threads wherever you're doing your core work. And all of this also works for Teams, which is pretty cool. But what's happening here is you can see it generated this like image, right? What's actually happening here? It created this big complex flowchart, which is pretty fun. But famously, block kit is only a subset of all UI that we can build in the world, right? It has like the ability to render cards. It has some buttons that we can render. We don't have too much control over it. We can adjust the color and stuff like that. What we're actually doing here is we're using something we call Channels UI to spin up a headless browser with a reactive component and take a screenshot of it and then send that back to the client. So you can actually use any component that you've already written inside of React or Angular. You can spin it up, take a screenshot of it, and send it back without ever editing your actual any of the UI that we just built a second ago, which is pretty cool. And then also we have the ability to like specify behaviors. So in this case, this only triggers when I mention it. So if I say @kite, do this, and then I can call thread.runAgent. And that's going to take care of all the logic of actually calling my agent behind the scenes. So if we recap what we just did, we just took a master agent. We gave it a React UI, built a pretty simple triage agent where we were able to visualize our incidents, get a dashboard for it. It asked us if we want to roll back, and we said yes. And then it was able to resolve the incident kind of in a flow with interactive components as opposed to us just typing. Our next thing that we're building, and one of the cooler things that we find from all of this is all of these threads, these interactions with a user are really great signals for learning. So if you've used something, actually I like to do this. Who here uses Cursor still? Okay. Who here uses Claude? Okay, a lot more Claude. Anyone a Codex fan? I'm a big Codex guy. I actually use something called Composer or Conductor, which lets me use all three. But all of these harnesses are actually using your interactions with the harnesses themselves to improve the harnesses and also the models. So this is what's happening with like GPT-5.3 Codex when that came out. Cursor took all of your interactions that we got from the last couple of years and built the, I think they call it the Composer model. Yeah, is that right? Oh, thanks, everyone. Nice, community. And same thing with Claude. They're all kind of like self-improving from the interactions that you're giving them, which is really cool. You can basically get this like recursive loop of improvement on your models because us interacting with them are really great signals for how to improve them. So what's also nice about Age UI is this is the same concept that they're all doing, but abstracted into a single set of events. And we also have the ability to get really well annotated human feedback from these interactions, right? I clicked approve. I could have also clicked deny. And you know, I won't get into the specifics, but you can get like kind of everywhere in between. You can have muddy and complex interactions, and you can annotate those really well because you're interacting with UI as opposed to just text, right? You don't have to do any like sentiment analysis on that. So what we're building right now is what we call the self-learning SDK, which is basically where we're going to take all of these interactions, we're going to trace them, create evals against them, generate skills for your agents, and then insert those skills into the agents. That's something that we're currently building. So if you're interested in that, come talk with me after. That's been my talk. Our whole thesis is to let users use your agent anywhere. If you want to talk with us, you can scan this. That'll get a link for you to book some time with our engineers. If you want to get started with any of this, you can run npx Copilot Kit Create, and they'll actually let you get started with a Monster app right now. So thank you for your time.
You mentioned that people could find you after, but how about we take some questions now?
Yeah, absolutely. Let's do it.
Cool. So if you have any questions for Tyler about Copilot Kit or maybe building agentic front ends, let's see some hands, and we can add to this gentleman here, please.
Thank you very much. Thanks for the talk. It was really cool. I think that generative AI is the future. Do you have examples or experience with generative AI outside the chat? You know, like you basically, the AI provides the user interface, but you never, it's more like a wizard that dynamically changes. What's your experience there?
Yeah, so one of the great parts about working at Copilot Kit, one of the things I love working here is that we get to see all of the different types of interfaces that people are trying to come up with. And I think that if I had to put it into kind of like two buckets, it's what we were calling workflows a year ago. I think it changes every day, and chat, right? And workflows are really like when I click a button and that triggers some AI, what does that look like inside of the UI? And that has a lot of really interesting implications, right? I think that one of the biggest ones that I've seen that I really like is search. Search can be agentic, right? And we can have really great agentic UX around that. So like if I go into a website and I type, actually if I go, Google is a great example of this. If I go to Google and I type like, how do I catch a salmon in Stardew Valley? And it comes back to me with some results. The first thing you see is actually an agent result. And I can start to chat with that at the end of it, but it doesn't necessarily mean that it is a chat-driven experience. I was just asking a question, right? That could be chat, or that could just be, hey, here's a response, and you never think about it again. That's kind of like the table stakes of non-chat. It still kind of is like chat, right? Like I'm still typing a message and then getting a response. But some other stuff that I've seen is like, you saw I was saying like, hey, there's an incident, right? Go resolve it. You can actually click a button and do that instead, and that goes and triggers a workflow. And I think that Monster has some really awesome concepts of a workflow where you can build some really nice directed graphs to get to some end state. And what the great news is that all of these events are generic. They're not necessarily result specific to chat. You know, models take input and send structured or unstructured outputs out, so text or JSON. we can map that to any UI that we want. So one of the demos I didn't show here is something that we usually refer to as shared state. I kind of glossed over it a little bit. So Monster has some really awesome concept of working memory, which lets your agent basically update its memory on the fly and do that in a structured way. AGUI actually lets you see that on the client and actually also update it bidirectionally, which is pretty cool. So your agent can see the memory and update it. So if we put all these together, the common use case that we usually showcase is like a to-do app, right? Where I go and mark some to-dos, and then maybe I open it in chat, or maybe ask the chat, hey, make a bunch of to-dos, and it can literally update the entire UI, as opposed to just living inside of the chat. And I have a lot of cool stories about that if you want to hear more. I'd love to get some more questions in.
That's right. There's one question here from the gentleman in the light blue shirt, and we can take one more after that as well.
Right. Yeah.
You mentioned tool call approvals as one form of feedback. Is it possible to define my own type of way to capture feedback, like a thumbs down on every message, and that is that possible?
It is absolutely possible. You're asking in the self-learning context?
Yeah, exactly.
Absolutely, yeah, it is. I think that thumbs up, thumbs down is kind of table stakes when it comes to self-learning. I think one of the things that our layer of the stack is uniquely enabled to do is provide you with even better, like non-opted in. Because you have to think about that. That's elective that somebody gave you a thumbs up or thumbs down. I never thumbs up or thumbs down my chat responses. I don't know if you do. And so that's elective, right? So you're only getting like a biased set of information. What's nice about this is the default flow of how to interact with your agent is what is being trained on, right? That's one of the nice benefits of it. But the answer is yes, you can absolutely do that.
Thank you.
Oh, there's a question here. Thank you. I have to say it's very cool being on this stage with you after we did this in SF a few months ago.
Yeah.
Now doing it in London. Feels oddly familiar.
Yeah, absolutely.
And yeah, as usual, some great questions.
Yeah, thank you very much. Question about mobile apps. Do you have any thinking about how you could do something similar for the mobile native applications?
For mobile notifications?
No, mobile native applications.
Mobile native applications. Well, first of all, we have, you're already able to do this today in a couple of different ways. We maintain the React Native implementation of all of this, so you can go and use React Native to build your cross-platform applications there. But we also have a bunch of community members that came, all of this is open source. AGUI is an open source and open governed protocol, and so we receive a lot of integrations and requests for different SDKs all the time. So a couple of the cool ones I've seen is Kotlin was recently contributed. We had a .NET SDK, so you can go and build native apps on Windows. That was actually contributed by Microsoft, which was really awesome to see. We recently also received Dart, if you use Dart. The one thing that we're still trying to get is Swift. So if you are a Swift developer, I would love to see a contribution from you. Or if anyone is, I'm certainly not though, but hopefully that answers your question.
Amazing. Thank you so much, Tyler.
Thanks.
Thanks, man. We were so lucky to have Tyler and Copilot kits at the event in SF about 3 months ago. And I just love this sort of passion and knowledge that sort of Tyler shares with us. I think it's tremendous. And we're really grateful to Copilot Kit as well for supporting the event. OK, up next we have Alfonso Graziano, who is an AI tech lead at Nearform, here to talk about building an open search research agent at scale. Give it up for Alfonso.
Thanks a lot. Hi, everyone. Thanks a lot for being here. Sorry, there is the clicker somewhere? Sorry, folks.
You have the clicker last time.
Oh, there we go. Thank you. Appreciate it. All right. Thanks a lot, everyone. Thanks a lot for being here. I'm very, very excited to be here. So yeah, today we are going to talk about how we built an open search research agent. The use case in this case is something that a lot of companies have, which is I need to have clever ways to talk with a lot of data that I ingested in a lot of years from a lot of different sources and expose everything through an agent or a multi-agentic system, as we will see. I'm Alfonso. I'm a tech lead in a company called Nearform. We are an AI native services company. We work across the globe. We are more than 500 people, and we work in a lot of regulated industries, fintech, pharma, a lot of cool stuff. Everything that I'm going to show today is done by the amazing team that I've led in the last 6 months. I can see a few people here in the room which worked with us in the last 6 months. So thanks to the entire team for the hard work. What I'm going to show you today, it's a very small portion of a bigger system that we built. In this case, we built this multi-agentic system, which is, again, it's just a small piece of the bigger software that we built. But long story short, what we built is a main agent, which is an orchestrator, which allows all the users, all the clients, all the users of our client to just go through the front end and then chat with every type of data. What we're going to see today, what we're going to focus today, is this data retrieval subagent, which is then connected to an OpenSearch proxy, which we're going to discuss in a minute. But then we also have a lot more capabilities. So we, for example, built a full customized RAG document search. We have plenty of specialized subagents for like very narrow use cases. And then we do have a lot of management tools with connectors. Everything is through our observability platform. And then, of course, as you may guess, we spent a lot of time building evals for this system. So ideally, if we got time later, we're going to talk about the evals as well. But let's focus on the architecture of this piece of system. So the problem, as I was mentioning, is a problem that a lot of companies have, which on paper sounds relatively simple to solve. So ideally, as a user, I want a user which asks a natural language question and gets the answer. Easy, right? That's what we told. That's what a lot of people think. So the flow is the user asks a question about whatever in the world, like everything that the company has access to. Then the agent somehow should be able to understand what's on OpenSearch, understand what's inside the entire knowledge of the company, build an effective query, which works and which gives the right result, of course, with a time budget. Like we don't want an OpenSearch query which destroys the cluster, right? And then the agent built an answer. This seems trivial. In practice, we will see that there are at least 3 main issues. The first one, which I'm assuming a few of you have seen in the past or are working at the moment, is that when you work on OpenSearch or other systems, you have the mappings, you have those fields, but those fields are not carrying a meaning. I mean, we know what they are because we built the system, right? But let's assume that I do have, I don't know, a field which is about wealth management. I have a field which says net worth. The only thing the agent has access to is the name net worth. It doesn't have access to the meaning of it, to how that data is computed, why that data is helpful. So we need a way to give a lot of semantic informations to our agent to work correctly and to give us the right answers. Then, of course, the other problem is, OK, I have an index, easy. I can just put the mapping into the actual context window. It's going to do something. It's going to build the query, easy. What happens if I do have tens, if not hundreds, of indexes, right? That makes things a bit more complicated. And what if the index itself is so complex that the mappings themselves are too big for the context window, right? So we need a clever way, especially because, of course, we pay by tokens, right? So we don't want to just put everything into the context window. That wouldn't scale. So let's start to talk about the first issue, which works for OpenSearch, but it's the same if you're using a database. It's the same if you're using pretty much everything else, which is a data model, essentially. So let me give you an example. Here there are a couple of examples. But for example, market value, right? I do have this type double. The agent reads market value. Now, if I don't tell exactly to the agent what this market value is, the agent is going to infer, it's going to think what this market value is. But when I built this market value, this actual field, I put a lot of my domain knowledge about it. So in this case, this is month and snapshot, not live, whatever, right? So we need a way to give all these informations to the final agent. How do we do that? We did something which is basically building a meta index. So every single field has, as we can see here, as the field name, the type, and then a full description. And this description is injected at runtime into the agent every time we need to carry the meaning of a field. And this is both useful for retrieval and then also for the generation of the answer, because the agent now exactly knows what these holdings, for example, is. Let's look at the other problems, though, because this was relatively easy for us to solve. But this is a bit more interesting, which is we have just too many informations. We cannot put everything into the context window. So that's the architecture that we built. A small warning before I tell you about the architecture. This is something that worked for our use case, for our client, and it worked very well. But in a different scenario, you might end up doing something different. So the architecture that we came up with is a basically two-tier architecture. So we have basically two agents. The first one doing progressive discovery. The second one building the query, running it, and doing self-filling. And we will look at them in a minute. So the first one is basically a search agent, which is trying to figure out, OK, I have this plethora, I have all this data. What are the fields and the indexes that I'm interested into? So that's the first step. Second step is, given the right information, given the right indexes, I need to build the right query. And if the query is wrong, if it doesn't work, I need a self-filling mechanism, which is building the DSL query, and it's fixing it. So for the progressive discovery, what we are doing, first of all, it's very similar to the concept of the scales. So what we are doing here, first of all, I am listing the indexes. So I do have a tool which allows us to list everything, see what it does with a brief summary of every index. It tells us what's inside of each one. And then we can, based on the real indexes that we really need, now we can run a describe index, which gives us a better description, some fields. It gives us more information. Once we have that, we want to understand the shape of the data, right? So we do something which is called described fields. So we basically try to tell to the agent, OK, I'm interested in those fields. Can you give me some examples? Can you tell me more about those fields? And so it's going to give us the semantic description of all those fields. Eventually, we are getting some field values. Because, for example, let's say that I do have an enum with like 50 possible items. I want to get some samples because I want to understand the shape of the data that I need to query. After we do all this stuff, eventually, we come up with something like this. So we start with a very, very broad search space. So how much of my portfolio is in crypto right now, for example. I do this discovery, and I found out that I have one target index in this case, but it can be more than one, of course. I find all the fields that matter for my use case. I find some sample values. And now I'm finally ready to go to the execution phase. This is an example of the discovery prompt. And that's how we built a very simple agent with Master. Of course, this is a simplified version of what we have. But of course, everything that we have built so far is built with Master. Now, the execution phase, which has been the most tricky to play with and to set up. So we do a few steps here. So first of all, once we have all these informations, once we know what is the research space, we start with a very broad query. So basically, we give the target indexes, all the fields. We give all this information to this execution agent, and we tell it to start to run a broad query. We understand if we have hits, And then, iteratively, we add the filters. We basically narrow down the search. And once the agent is happy, then it's going to return us the business answer plus every search notes. I just want to stress here why the semantic meaning of each field mapping is important. Because we want to give a business answer. We don't want to just give a number. We don't want to just give like a few fields information. We want to be able to tell the story to the final user of what this stuff is and why it matters to the user. Then, of course, things might break. Things always break, right? So in case something breaks, we have a few possible error cases, right? The response is too large. We don't want to float the context window. The DSL, the query itself is broken somehow. There is a wrong value that we are sending, right? So this is the self-filling loop that we have. And basically, the agent is able of fixing itself iteratively. This is an example of how we are of our prompt to actually build the DSL query. If you're interested, if you're an OpenSearch user, there is here a beautiful prompt template for the query planning, which is in Java. So what we have basically done, we have taken all this information from the Java template, we ported it into Mastra, and then we did a lot of refinement to make it work a bit better on our use case, because we found out a few edge cases where it wasn't working for us. But eventually, we are just giving as many information as possible to the execution agent on how to run and how to build a great OpenSearch query. Now, permissions is a very big topic for us, and I'm sure that everyone here struggles with permission. So what we usually do is, instead of our agent going straight to the OpenSearch cluster, we have a proxy in between. And basically, thanks to the master request context, we send every information about the user to the OpenSearch proxy. The OpenSearch proxy is basically doing a rollback access control, rate limiting. It has a rules engine. It does session restrictions. It can change values at runtime. So it can do a lot of stuff for us. And then we only focus about building the agent and ensuring that the agent works. Let me give you a very quick example of why the OpenSearch proxy is very useful. Let's assume that I do have a user. Like our agent has access to the entire OpenSearch cluster. But if our user doesn't have access to maybe one feature, or maybe doesn't have access to a few fields, I can just tell to the agent, hey, by the way, those are all the information that you asked me, right? But please, dear user, be aware that at runtime, I couldn't give you access to, for example, the market value or whatever, or any other field, because you don't have the permission, or there is another reason why at runtime I had to remove that value. So thanks to this technique, we can actually make a few changes to the response before we give it to the agent, which is way more secure. That's how it looks like, actually. Not sure if it's very well visible, but this is a real-world example of what we built. So we have here the first discovery agent, and then we have the execution agent. As we can see, the discovery agent is doing the list available indexes, is describing the indexes, is understanding everything, is describing the fields, getting some fields values, and then it's running the execution step. So it's building the DSL query, it's running the OpenSearch query, and it's just going deeper and deeper until it finds the actual solution. And yeah, this was our architecture. Thanks a lot for your time and attention.
Can I ask you a quick question?
Yeah.
I've noticed you wearing this open source is art, and maybe you've got some other folks at Nearform wearing it.
Absolutely.
What's the meaning behind that?
So actually, Nearform has a very long story of contributing to the open source. Mm-hmm. We actually contributed to Master as well, nice. with a few PRs, which is great. So every time we do client work, every time we support our clients, we try, to contribute back to the open source ecosystem. We have a very long story of contributions to Node.js Core. some of our packages, I guess that some of you might know them, like Pino, Fastify, they're born in Nearform, and then of course are free for everyone to use. So we really love open source.
That's very cool. I love open source, and that's a beautiful t-shirt. Thank you again.
Thanks a lot.
Okay, folks, we've made it to lunch. So just a couple of things to let you know about. I mean, first of all, maybe you've seen these books floating around in the main area. The first time I saw a book like this, I thought, oh, I'm not sure if I'm allowed to take that. It looks quite nice. But you absolutely are very welcome to take a copy of each. And in fact, you can take multiple. We have a lot to go around. And what I sometimes find is that people want to take them for their team or to share with their friends. So please do help yourself. And if you want to get a copy of the book signed by the author, who is Sam, Master's co-founder and CEO you saw earlier, he's going to be doing a book signing nearby, near the staircase. So you can go and hang out and ask your questions there. If by chance you're interested in anything that you saw earlier in the keynote from Sam, Shane, and Abby regarding Mastra, we're doing something unique for the first time here at TSAI, where we have a demo corner set up. So head over there, find someone in a pink t-shirt. You can ask about Agent Builder. You can ask about the Mastra factory Shane was talking about earlier, and they'll crank out their laptops and proudly show you a demo. We're going to take a little break now, and we're going to reconvene at 1:40 p.m. So in an hour, please go and enjoy some delicious food, coffee, meet some fellow folks, and we'll see you back here in about an hour.
Every week in AI, something insane happens.
And there's so much drama. Every Monday, we break it down live.
We do the news, we bring on guests building in the space.
And we go deep into the stuff that actually matters.
Agents Hour, every Monday, noon Pacific.
Follow. Don't miss it.
Peace.
Through the sunshine on my mind. We're burning through the city of lights. You're the sunshine on my mind. We're burning through the city of lights.
It's hot in France, folks, so let's take it slow. You got a workflow, we can watch it go. Step one, simple run. One task, one result. Click it, read it back. Find the first fault. Now check the trace. drifts off path, you'll know in time. Check each step, keep it clear, keep it clean. Check each step, so the flow can be seen. Next comes parallel, split the road in two. Watch both branches move, see what they do. One side may finish fast, one may lag behind. Match the output lock, stay one step in line. And test the branch when the choice turns. If the condition hits, you see what it returns. Check each step, keep it clear, keep it clean. Check each step, so the flow can be seen. Then loop it once, then loop it twice. Count each turn, keep the same device. If it repeats too long, if it skips too soon, you follow every turn till the whole thing's true. Check each step, keep it clear, keep it clean. Check each step, so the flow can be seen. Listen close, here it goes. Small signs on the screen, tiny sparks in the noise. Pattern after pattern, I'm learning your voice. Every pause means more, every click leaves a trace. I'm reading the edges, finding the shape. Show me the next cue, show me the frame, I catch the motion. I learn your name, learning signals, one by one, learning signals till I've got the run. Learning signals, show me how, learning signals, I'm tuned in now. First a little rhythm and a softer bend. Repeat it one more time and I see the trend. Simple inputs line up, little lights awake. What starts as a whisper turns into a show me the next cue, show me the frame, I catch the motion. I learn your name, learning signals, one by one, learning signals till I've got the run. Learning signals, show me how, learning signals, I'm tuned in now. New rules, new timing, new ways to read. I'm taking the pattern France, folks. So let's take it slow. You got a workflow. We can watch it go. Step one, simple run. One task, one result. Click it, read it back. Find the first fault. Now check the trace, line by line. If it drifts off path, you'll know in time. Check each step, check each step. Keep it clear, keep it clean. Check each step, so the flow can be seen. Next comes parallel. Split the road in two. Watch both branches move. See what they do. One side may finish fast. One may lag behind. Match the output lock. Stay one step in line. Then test the branch. When the choice turns, if the condition hits, you see what it returns. Check each step, check each step. Keep it clear, keep it clean. Check each step, so the flow can be seen. Then loop it once, then loop it twice. Count each turn, keep the same device. If it repeats too long, if it skips too soon, you follow every turn till the whole thing's true. Check each step, keep it clear, keep it clean. Check each step, so the flow can be seen. Listen close, here it goes. Small signs on the screen, tiny sparks in the noise. Pattern after pattern, I'm learning your voice. Every pause means more, every click leaves a trace. I'm reading the edges, finding the shape. Show me the next cue, show me the frame. I catch the motion, I learn your name. Learning signals, one by one, one by one. Learning signals, till I've got the run. Learning signals, show me how, show me how. Learning signals, I'm tuned in now. First a little rhythm and a softer bend. Repeat it one more time and I see the trend. Simple inputs line up, little lights awake. What starts as a whisper turns into a show me the next cue, show me the frame. I catch the motion, I learn your name. Learning signals, one by one, one by one. Learning signals, till I've got the run. Learning signals, show me how, show me how. Learning signals, I'm tuned in now. New rules, new timing, new ways to read. I'm taking the pattern, I'm planting the seed. Learning signals, one by one, one by one.
I hope you all had a delicious lunch. We're going to kick off the second half of the day right now. 7 talks down, 7 more to go. We have some amazing speakers coming up, including Elastic, Factorial. We have Autumn up next. I was just curious to learn a little bit about us as a crowd and where you came from. Can you put your hand up if you're based in London and you just came down the road?
What is down the road?
Anywhere in the greater area, London area would be fine.
Well, I would say Wembley, but
That is 100%.
down the road.
It's not really a short walk, is it? But I'll take it. That's. So who here came from abroad? Okay, so maybe 50-50. Keep your hand up if you traveled more than 2. Put your hand up if you came here from abroad, and keep it up if you traveled more than 2 hours to get here. Okay. More than 4 hours, keep your hand up. Are we getting credits? Pardon? Credits. We'll see. More than 6 hours? Whereabouts did you travel from? Miami. From Miami, nice. Who else has traveled more than 6 hours? Whereabouts did you travel from, Alfonso?
Naples.
From Naples, nice, cool. Did you have your hand up, Marvin? Because I'm pretty sure you're from France, and that's not more than 6 hours away. Anywhere could be more than 6 hours. It's probably 6 hours to walk from Wembley. Okay, let's crack on with the next talk. This is from a team and a company called Autumn, which help you add billing to your AI applications. I've been aware of Autumn for a little while as a YC startup and eagerly following their journey. They're doing this amazing thing where they are always iterating on the product, taking on user feedback. It's the kind of philosophy, I think, that makes for any great product. So please help me in welcoming to the stage Autumn's co-founder and CTO, John Yeo, and Charlie Lamb, their founding engineer.
Thank you. Hi, everyone. Thank you, Alex, for the nice intro. My name is John. I'm the CTO of Autumn. And this here is Charlie. He's our founding engineer. And today we're going to be talking about why monetizing agents need different infrastructure. And so Autumn is, as we said, billing for AI companies. But what does that really mean? I think the way I like to think about it is that we are billing for modern companies. And so historically, like a decade ago, billing was very much just subscription-based. You would just charge something every month. And then, a couple years back, we got into this interesting period where it was very much usage-based. So all of these infra companies started popping up, and you would have, you would basically want to charge based on, say, compute hours that you would accrue over the entire cycle and charge through an invoice at the end of the month. But we're sort of seeing an interesting pattern come with AI applications where billing is now a lot more tied with your application. You have these things like tokens and credits and actions that you want to check for upfront before a user actually makes a request. And that requires sort of a different infrastructure, right? And so that's what we're going to talk about today. We're going to give you sort of a preview of what that looks like under the hood in hopes that maybe you could implement this at your company, or maybe just share some tips in terms of how you can solve some of the problems that we've seen other companies face. So to set the scene, imagine you're sending a message in Codex and you see this error. You've hit your usage limit. I'm sure all of y'all have probably hit that if you've been token maxing enough. But on the surface, it seems very simple, right? Maybe it's just checking Redis as a rate limiter, or it checks Postgres. But today we're here to show you that there's actually a lot that goes under the hood, especially when you think about high throughput, concurrent, atomicity. And so now I'm going to let Charlie go into the first portion.
Cool. So we're going to start with a very simple example. We're going to be building out the billing system for an AI coding assistant. We're going to give all of our users 100 messages per month. We've already got a customers table in our database. So to facilitate this, we're just going to add a single column and give all of our customers a balance of 100. Whenever we go to call the model, we're just going to do a simple Postgres transaction, check the balance, and then track the usage from it. Now, this gives us safe concurrency without needing to call Redis or some sort of external key. This is a very basic billing setup, but for this use case, it works pretty well. And we're going to see how it struggles to scale. So let's say, for example, I want to add promotional codes to my application. And these promotional codes gives me a lifetime balance. This is different from the balance in the database right now, which resets every month. So how am I going to do this? Well, I choose to add a new column in my database. I'm going to call this lifetime balance. And this is going to reset separately from the original balance. Now, to be able to facilitate this, I'm going to have to add more application logic in my code base. I'm going to have to do a database migration. And overall, the change is quite complex. So you can imagine if I then add like auto top-ups, if I then add rollovers, this is going to get like very complex. I'm going to have to do lots of migrations and lots of changes into my application logic. So we should take a step back and think about a better way to do this. And that would be moving to a row-based approach. So let's create new tables, balances. And we're going to add a row for every single balance. So for our monthly balance, we're going to add a row. For the promotional balance, we're going to add a row. And for any auto top-ups, we're also going to add a row. And all these balances have their own expiries and their own metadata. So this does make tracking a little bit more difficult. We now have to track over multiple rows. We have to choose which balance we want to deduct from first. We can do this with like consistent algorithms. Say, for example, I'm going to take from the most recently expiring balance first. And yeah, this is a much better system. So now we know exactly what our balances are. We now have a different problem. We don't know how they got in this state. And to fix this, we're going to add a ledger. So this ledger is going to give us all the historical information we need to know about our balances. Every time we delete a balance, every time we create a balance, and every time we track users from this balance, we're going to add an event in our ledger. And this means that at any point in time, we can go back and see exactly what the balance was and how it got there. Now, for us at Autumn, this is really useful. We have a Slack bot that all of our customers use. And this will like go through the ledger, see exactly how the balance got there, who added the balance, who deleted it. And it really relieves us of a lot of customer support work because we have a ledger which says exactly how the balances got in that state. Now, when you have a ledger like this, it can be quite tempting to calculate the balances from this ledger. So I can create like a materialized view or just aggregate over all the events in my ledger and calculate the balance like this. This is a good approach if you have like some billing, which you calculate the balance at the end of the month. Maybe you're showing something on a dashboard. But for our AI coding assistant, or how we do billing at Autumn, this doesn't quite work. So we also need a counter, potentially in Redis, which has the current value of the balance. And we can check this value very quickly without having to do any complex aggregations or anything like that. So using the two in tandem is really the best architecture in this case, and that's what we'd recommend going for.
All right, yeah, so Charlie mentioned how he sort of laid out the groundwork for like our credit-based system. You have Redis as a counter, you have a ledger, which it might be stored in ClickHouse. But now I want to sort of focus on the case where you have very high throughput, and each of these requests need to be handled atomically, which is probably the case for a lot of you guys if you're building, say, an API, right? Which is, I think, very relevant in today's world of AI. Everyone's opening up MCPs, and everyone's handling tons of requests per second. And so conventionally, the way you would solve high throughput scenarios is that you would simply take each event and send it to something like a queue. And these events would then be processed asynchronously, right? But the problem with this is that with AI, it warrants sort of a different framework because with an asynchronous method like a queue, a lot of these event deductions happen in a background process, and so that means there's a lag. And you can imagine in the case, if you want to go to the previous slide, if you have several agents that are just like spamming concurrent requests, each of these are not going to have the real-time balance, and therefore the customer is going to be able to go into overdraft, and a lot more credits will be used. And so the architecture that we see a lot of people adopting today is something more like what we call a lock and release. And so you can imagine something like with ChatGPT, when you send a message, it will first estimate the number of credits that your message is going to use, probably by the length of the message, the estimated number of input tokens. It will then deduct that atomically from your balance. It will process the request, and then following that, it will either refund if you've used less credits than what was predicted, or deduct even more. And this way, if you have 5 concurrent requests coming in, let's say each one costs 100, and you only have 100 credits, one of those requests will go through, and the other 4 will be rejected. And so this way, everyone's balance is very much more accurately handled, right? And one thing I want to talk about here is that infrastructure-wise, it makes sense to do this with a Postgres transaction. But we're going to see later on that billing systems get very complex. And I think if you've worked with one before, you probably know that there are many joins across many tables. And it's not as simple as just saying, oh, let's lock one table, perform a transaction, and then release it afterwards. And so the way we've seen work generally quite well for many companies is that you can use a Redis cache and atomically deduct credits via Lua scripts. And this is much faster in terms of reads and writes. And so maybe the next thing, sort of to wrap things up, we've talked a lot about credits. And what I want to talk about now is how to make your billing system flexible, which is very relevant today as well, because AI is very unknown, and a lot of people don't really know how to price it. And I think you've probably seen by now that people are making pricing changes at like 3x or 4x the rate that they used to. And if you've ever done one of these yourself, you know that it's actually like insanely difficult. And so hopefully we're going to give you a bit of gold nuggets here on how you can make that simpler. And so the first mental model that I would try to hold when thinking about how to create a flexible system is that billing is relational. Now, a lot of y'all probably think that with billing, all you need to store is your customer state. You might have one table with each customer, user ID, credit balance, plan, and whatnot. But that is only treating one part of the problem. Ultimately, with billing, every part of the system, the plans, the entitlements that your users get, and the customers themselves all change. And by designing it as a system like this, it becomes much more flexible and much more, seamless to create billing pricing changes. So you can imagine if we wanted to create a new version of Pro, all we need to do is add a new column. All of our current customers are grandfathered, and whenever we want to switch them over, we can simply change the foreign key on the customers table. And likewise with entitlements. It's much more cohesive. And yeah.
So I think it's also important to remember that your billing config should be hierarchical. And what I mean by this is if I want to create like a usage limit, for example, I want to limit all of my customers to 10 messages per month. Now, if I wanted to do this and add it to all of my customers' rows in my database, this would be a big change. I'll be adding thousands, if not millions, of changes to my database. The best way to do this is to have some sort of global configuration in which all customers use. And then let's say, for example, I want to add more complexity. I want to introduce a Pro plan with a different usage limit. Let's say 25 messages per month. It makes the most sense, instead of changing all the customers, to add a configuration at the plan level. So I'm going to have this config at my plan level, and I'm going to have some sort of logic in my application, which goes through it first, looks at the customer, looks at the plan, and then looks globally and says, is there a usage limit? And this enables us to resolve it in a much more like a hierarchical way. And let's say, for example, the CTO wants unlimited usage. I can just add a configuration at the customer level, give them unlimited usage, and a hierarchical sort of structure works really well. So yeah, thanks for listening to the talk. We've covered a very simple billing system. We just added a single column to the customers table, and we've added complexity. We've added more complexity to our product, and also more like load and scale to our system as a whole. And yeah, hope you learned a lot, and thanks a lot for listening.
Thank you, guys.
Nice one, John.
Thanks.
Thanks, Charlie.
Thanks.
OK, so next up, we have Carly Richmond from Elastic saying, yes, even your TypeScript agents need retrieval. Give it up. Thanks, Carly.
Thanks. Good. All right, everybody, how are we doing? We're still awake after lunch. That's awesome. Right. You're just going to have to bear with me a minute while I plug in my laptop. Here we go. And now we should see some slides. OK, right. Hi, everybody. I'm glad you're all awake. It's great to be here at TypeScript AI, and it's nice to be at a local conference in London. As Alex mentioned, my name's Carly, and I'm going to be talking about retrieval. Now, when it comes to retrieval of AI agents, well, we need to talk about a few factors here. We need to talk about the fact that we still need it and why we still need it. We need to talk about RAG. yes, RAG still exists, and the evolution of it and all the options that we have available to us. We need to also talk about BM25 and vector search, when to use one over the other, and then I'll briefly touch on re-ranking and relevance scoring, and we'll hopefully use a nice Master AI agent as an example to highlight each of these concepts. So I've already had a nice introduction, I don't need to go any further, but my name's Carly Richmond. I'm a Senior Manager in Developer Advocacy at Elastic. If you have any questions, we'll have Q&A at the end, but otherwise, come find me. I'm really happy to chat. So, we love a buzzword in AI, don't we? We've had harness engineering, we've talked about factory engineering earlier today. Context engineering was the one of last summer. But I'd say it's still very much relevant and useful for us in the building of agentic systems. So do you all know what context engineering? Hands up. A big chunk. Well, if you don't, then we'll get to it in a minute. But the whole point of context engineering is to make sure that we actually get the correct information passed into the agents, irrespective of whether we're talking about vanilla chatbots or we're talking about more complex ones that are using data to make decisions. They need access to the correct information. So throughout this talk, we're going to make reference to this example, which is a super simple example that's pulling in relevant data from an Elasticsearch cluster and using it to answer the relevant questions as we go. We'll talk about vanilla RAG, and then we'll talk about the tool and how these things compare and contrast. But context engineering, in really simple terms, is basically the set of capabilities that we can use to manage the context window to make sure that we have the right information passed to the LLM for any of the agents that we're building, irrespective of framework and technology. So RAG we will focus on as a big chunk of this presentation, but we also need to remember that the instructions and prompts are an important consideration for the data that's passed in, as is long-term memory and access to tools. And part of our role in building out agentic systems is making sure that the right information is available so that these systems are going to function as they should. Now, who's ever asked an LLM a question and got back a bit of an iffy answer? By iffy, I mean, it doesn't look right. I'm a bit scared that only half the room have answered, so now I'm curious as to what people are asking LLMs. So I've had this happen to me on a couple of occasions, and it happens for numerous different reasons. So it can be down to the model we're using being trained up to a particular knowledge cutoff date. So if I'm asking a model that has a cutoff date of November 25 about the World Cup from the World Cup scores over the last month, it might end up giving me the ones from the last World Cup. So that obviously is a bit of a knowledge problem. Less of a problem for foundational models, but over and under fitting is something that we might end up encountering with some smaller models that we use. Biases in data, there's been countless examples of not particularly in earlier LLMs, but even currently LLMs exhibiting biases in their results. And if we are building, financial agents that are making decisions and they end up using that data in a negative way, that's a big problem. There's language ambiguity. I don't know if anyone's had to help their kid, like me, with my 6-year-old and his English homework, but the English language is full of it. And catastrophic forgetting, where they basically have a brain fart and forget realms of training data. And these are the kind of challenges that we need to face when we're building agentic systems. But we also need to take into consideration that, as kind of surmised by Georgia Tech and OpenAI researchers last year, they actually reward the evaluation procedures that these are being subjected to is rewarding guessing over acknowledging uncertainty. And that's a problem as well, because if, anyone who's had to take their, trying to tell their child off for doing the wrong thing, anyone who has pets and is taken to obedience training, all of these things are, you incentivize the wrong thing, we shouldn't be surprised that, the child or the pet does the wrong thing. So we need to bear that in mind too. Now, when it comes to retrieving information for AI systems, we've already talked about the numerous different facets in context engineering that we can talk about. But one of the main mechanisms we have is RAG. And RAG here, who knows what RAG is? I'm hoping most of the room. Yeah, so we don't need to come through this in a lot of detail, which is good. So one of the things that we need to think about with traditional RAG is it's a fixed pipeline. It's going to pull out the information once, and it comes at pulling out that information not multiple times. It's irrespective of the need for follow-up information. So it's always going to be called once. It's not like agentic tools where we have a choice and the LLM can make that decision. Now, we all know what vector search is, right? Does anyone need a reminder? No. Right, so for anyone who's just staring at me, semantic search typically leveraging vector search, which is where we generate an embedding, which is a stream of numbers a lot longer than this two-dimensional example I have here. And all of the results that we have tend to cluster closer together if they're considered to be semantically similar or relevant. So that's why we have the example here where, if I was looking for Han Solo as my query, for example, through vector distance of simple cosine similarity, it will resolve to being similar to Luke and Leia and completely opposite to my cartoon Vader on the other side. Lexical retrieval, I hear a lot of people saying we don't need lexical retrieval anymore, and actually lexical retrieval is still good for exact matches if you're looking for company names and things like that. And for those who are not familiar, the way that lexical retrieval has always traditionally worked is utilizing an inverted index. So we pull out the relevant tokens and we store those along with a reference back to the document in which it resides. And then we'll use traditional algorithms such as TF, IDF, or BM25 in order to actually calculate the relevant score to figure out how relevant a particular document is. And we can use both of these within our own agents. So let's dive into some code. Wave at me if you need this to be bigger. Wave, okay. Big enough? Thank you, cool. Right, so this is this agent using Mastra that I showed you in the start. And what we're going to be using here is the Elasticsearch vector store contributed by one of my lovely former colleagues to the Mastra ecosystem. So this is going to handle all of the interactions that we're having between Elasticsearch within our agent. So whenever it's going to do something, it's going to call this particular store. But the store can help us with other capabilities. So it can create the index for us, and we would need to specify the dimensions of the embedding model for that. But obviously that means we can sort out the kind of spin up and tear down of the particular stores as well. We need to also generate our embeddings, so we're able to do that utilizing the OpenAI, the embedding model here, and I'm using text embedding 3 small. Then what we need to do next is once we've got a hold of the relevant documents that we're wanting to generate all the embeddings for, what we're going to do is create a document from the text using the mdocument abstract and then chunk things. So chunking strategy is something we need to think about. Recursive tends to be my go-to default, but that can be a factor if you're not getting results you quite expect. Then what we do is generate an embedding for each of these chunks, which is just doing a do embed option. And then finally, when we actually get the final results through, if I scroll down here, you'll see we use an upsert, and that's going to insert the embeddings in. And when we do that, we end up with a set of numbers like this. Now, when it comes to actually searching, we do the same thing. You embed the query, and then you do a query against it. So the example here with Elasticsearch vector in the router is once we do the embedding, you do vector store.query, and that's how I end up with these particular results that I did earlier. So you'll see here that I've got, for this query of sci-fi movies with a strong female lead, the top result is Vegas in space. And then because of the chunking, I've ended up with 4 instances of Barbarella. So again, being careful about our chunking. Now, I said before the notion of a fixed retrieval pipeline and RAG and the fact that it's called exactly once. We don't tend to really do that anymore unless you want this guaranteed providing of context. So what we'll end up doing instead is building it into a tool. And that's what agentic RAG tends to be, this idea of having a specific tool that will pull in the relevant information. Now, this could be using traditional vector search. You can also do the aspect of metadata filtering. So one thing I didn't call out in my prior demo was that you can actually do filtering on top. This can actually be a nice way to reduce the number of vector comparisons that you're performing, which obviously are quite costly. So it's another thing to think about as well. It's not just semantic. We can combine these approaches together. And then we can combine it with other sources, like your vector database is going to be a source of truth, but it's not going to be the only one. We're building out systems that are utilizing skills, are utilizing web searches, all sorts of different sources. And our job has become curating that and trying to get the right results out of it. So in order to adapt that example that we had into a particular tool, all we need to do is pull this down. And we need to create a vector query tool specifying the store. Now, you can also enable filtering, and that enables metadata filtering utilizing lexical, and that gives the LLM the capability to add those options in for you. And then we'll talk about the other things later. And then in order to use that within the agent, all we need to do is create our new agent and add it to tools. It's really not complicated. And that then gives the LLM the choice to dictate whether we need that relevant context or not. One of the things we need to think about when it comes to agentic search and we're building out tools either in MCP servers or indeed in native agents like the example I've just shown, is that they might not do what we quite expect depending on the queries and the options coming in. So we have all these edge cases that we need to think about. Our happy path is going to call the right tools with the right parameters and everything's going to be fine. But we all know in the real world in building agentic systems, it doesn't always work like that. We have instances where it doesn't call any tool at all. It might call the wrong one because you have two really similar ones in the catalog and it can't discern between which one is ideal for this situation. And indeed, you can have the situation where it just calls it with completely wrong parameters and we end up with errors and problems, similar to the example that Rachel showed this morning in her demo, where you had basically it was returning back an error because it couldn't pull out the relevant table data. We need to actually start engineering and taking more care over the tool descriptions we provide, not just when it comes to search and retrieval tools, but any tool within our agent. So one kind of rule of thumb that I like to come through is prompt engineer the tool description. Prompt engineering is not just for prompts. We can tweak and add in information such as the purpose of this particular tool, what's going to trigger it, what is it actually doing, is there any limitations to it, what are the relationships to other tools to help it understand when to use one over the other, and then examples, particularly leveraging parameters to make sure we cover the equivalence cases so it knows exactly how to call these particular tools, and then reinforce that in the agent's prompt as well so that it has knowledge of these tools and it knows where to go to try and get more information, i.e. the tool description itself. But we also need to curate the right set of tools to start with, because if we have really general purpose tools that are generating full queries, so for example, this generic search one that would have what we call a high ceiling, those are fine, but they're more likely to have the chances of error and they can be really difficult to try and get right. However, the opposing problem is you end up with loads of really specialized tools, such as get top product by category at the bottom, which don't give you the flexibility. What if I want to look by location or another attribute? This isn't going to be useful for me. And so part of the trick when it comes to retrieval is finding the right tools to provide as the LLM context. Now, whenever I talk to people about building agentic systems, they're really focused on the performance and they're focused on how quickly the response is coming back. That's great, but if you're bringing back really quick results that are not relevant and are actually completely useless, I wouldn't consider that a win for the performance of your agent. So we need to look and see if the results are actually right. Because we can have all sorts of different issues appear when we don't have the right relevant data coming through. So for example, if we have queries requiring exact matches, that can potentially be a problem. If our chunks are too small or too large, then obviously that means we might not get the relevant information we need through. It can be that we've maybe picked an LLM that's more general purpose rather than a language-specific one, which can have issues such as in healthcare or in finance, where we have really specific jargon-heavy language, not just in IT, where we love jargon too. All of these issues, aside from retrieval, are something that we need to capture. Now, you need to fix a lot of these within your pipeline, but sometimes if you've got an established pipeline and it's just more that your results are maybe not quite as in the right order as you expect, then we can utilize re-ranking. So who's heard of re-ranking? Not many of us, but a few. Right, so re-ranking is a really simple idea where, ignore the reciprocal rank fusion for the moment. The general idea is that we have a particular algorithm that's going to take in a set of documents along with the query, and it's going to reorder it according to particular characteristics. Now, obviously, reciprocal rank fusion is one possible approach, which is where we basically take the summation of all of the scores. You can apply a particular constant as well over the top, but k of a 60 is normally a sensible default according to the literature, and that's a way where we can reorder our particular results. Now, you can also do re-ranking in Mastra utilizing a linear combination-like approach. So if we go back into our tool, you'll see that I've specified in the re-ranker the model, and I've also added in weights. Now, linear combination can be really flexible, and it can give you good capabilities to reorder, but part of the problem you can see is that you need to figure out what these weights are. So if you're not sure, then potentially going down the route of RRF can give you some sensible defaults back. Now we can also look at re-ranker models. That does mean you have to add another model on top, but you'll see it works in a very similar way. We take the retrieved documents, we take our query, and we'll re-rank those as well. And I have to give a call out to Gina. So Gina is one possible reaction model. There are others available as well. And I like Gina because it's available on Hugging Face. It's also available on Elasticsearch. So if you want to have a play about with re-rankers, go and have a look at those. But when it comes to scoring as well, you need to actually score in the first place. And one of the other things that Rachel mentioned in her talk this morning was scorers. So we can actually utilize the inbuilt relevancy score to actually look and see how relevant the results are that are being returned based on top of the documents in our model. So if we go back to Master Studio in here, this is all the executions that I've done earlier. And you'll see here for that particular query of the sci-fi movies with a strong female lead, we're getting a result of 0.54, partially because it's bringing in like TV shows, which is not as relevant as movies, but it's giving us the other ideas of, what's potentially wrong that we can go and try and tweak and evolve what we're doing to see if we can get the right results. So we've talked about retrieval. It's still needed. It's still necessary. At the end of the day, if the right information is not in there, as my old maths teacher used to say, rubbish in an LLM, rubbish out. We've talked about re-ranking, we've talked about vector search, and we've talked about the evolution of RAG, and obviously how these can be used within agentic systems. If you want to check out the code, the QR code is there, and we have a few minutes for questions if anyone's interested, and thank you very much.
Thank you, Carly.
Thank you.
I really enjoyed those demos, and that was a very good intro to RAG.
Thank you.
Very cool to see Master Studio there as well, and you bringing some of the pieces together.
You're welcome. Thanks.
Do we have any questions for Carly? One question here. We'll just grab you a microphone, and then, sorry, could you raise your hand again, and I'll remember you for the next question. Thank you.
Thank you. A question I've got about data stores that hold like millions of documents that are almost the same.
Yes.
How do you use re-ranking or the other technique or some other technique so that you don't just get noise back in your top 20 or your top 50? You get something relevant, something different, at least one of the 20 documents that are the same. Have you got any ideas around that?
So there's a few things that you need to do. I mean, re-ranking is one option, but at the end of the day, if your top 20 or your top 50 don't have the relevant results to start with, and you're pulling back 20 or 50 documents, then obviously the re-ranking is probably not going to solve the problem that you've got in that particular instance. What you'd want to look at there instead is probably query profiling and tuning. So you'd actually want to look at the query that's being performed in the first place, and then also, look at the results that are coming back and then figure out, perhaps do I need to add in additional filtering? Is it actually that my query's maybe not quite right? So when it comes to, it's really easy when we talk about embeddings to quickly get to a billion vector situation. If you have a good few million documents, you're going to end up with potentially a billion vectors. So in those particular instances, you need to look at kind of the queries. You need to look at maybe how doing more aggressive filtering to kind of pre-filter out some of the particular results before you do the vector comparisons. And you can also, again, look at the type of embedding model you're doing. If it's not picking up particular characteristics, that might be impacting the results as well. So you could also look down that avenue. Does that make sense?
Partly, thank you. I think I'll come talk
Come
to you.
find me after. We can chat through.
Thank you, Derek. There was another question in the back corner here, Leonard. Thank you so much for running the microphone.
So how do you handle misspellings or partially entered words, such as the user enters HAM but wants to search for hamburger?
So LLMs can partially deal with that, but in traditional search, you would look at using different fuzzy approaches. So you can use fuzzy filtering, which will basically kind of allow for particular swaps. So that's one thing you could look at. You could also utilize traditionally synonyms as well. So using synonym expansion to capture like common misspellings. obviously that means that you get a really large synonym list, so you need to factor that in. But I've seen people using semantic search to address some of that, and I've also seen people using the fuzzy n-gram capabilities. So if you have a look at both of those, they can probably give you what you need.
Thank you.
Amazing. One more question here from the gentleman in the short sleeve blue top. Please, Leonard.
Okay.
Thank you. Hi. On the topic of semantic similarity and very large volume of similar documents or rows,
Mm-hmm.
Do you have an experience or any recommendation in terms of when to apply clustering, if it is a process during the ingestion and embedding side, or at query time trying to group sets of documents?
So I've not got any experience with the clustering stuff, I'll be brutally honest with that. I mean, whenever I've dealt with the clustering stuff, it's more around more of the quantization side, which is the compression, not around trying to identify particular candidates. I'll be brutally honest about that. Again, it kind of comes down to if you've got a large number of comparisons, you can obviously tweak, as we talked about, like the pre-filtering and things like that. You can also start looking at tweaking like K. And also in some vector databases, you have an option for tweaking the number of candidates that are actually compared. So for an example in Elasticsearch would be using the num candidates option. So that basically means that you would compare more similar vectors in order to try and boost the accuracy, but the trade-off is that you're doing more comparisons, so therefore the results take longer. So another thing you could possibly look at as well, now that I think about it, would be the number of candidates. But on the clustering stuff, if you've got a particular question, come and find me. I'm happy to take it away.
I'll do that. Thank you.
Thank you.
Carly, thank you so much.
Thank you.
Thank you. Factorial is a company with 25 sub-products. Some of them are catered to specific markets. And to move quickly and to cater to these different markets, Factorial needed a good abstraction and a good harness. And so I'd love it if you join me in welcoming Ilya to the stage to talk more about Factorial and what they've been building.
It's a long walk. I'm doing my fitness day. Oops. Hope it will work fast.
It takes a second, I think.
Magic. At least my Mac shows that it's okay.
There we go.
Okay,
Good.
awesome.
Give it up for Ilya.
Just this morning, I understood that Master's logo and Factorial's logo, they're kind of still about the humans and connections, so I couldn't skip this opportunity to do the same, to do this morphing. But in the end, yeah, I'm Ilya, I'm from Factorial, and today I want to tell you a story, how we put AI in the center of a 10-year-old SaaS, because that was a kind of a huge technical journey with a lot of experiments and a lot of failures. But for you to fully understand why it was kind of complicated, I need to give you some context about what Factorial is. So 10 years ago, the company was born with a simple vision, is that we want to help small and medium businesses to automate boring things so they can focus on what really matters, their customers. And everything that is mundane and really like day-to-day work of the company, we can automate that. So we started with HRIS and time, two things. So HR can have company employees with contracts, and then employees can ask for vacations and do clock-in, clock-out in the offices, because it's a Europe thing, easily. That was another point that we wanted to stress out, is that we wanted to create a product that employees really love to use. They don't hate the product that they need to use daily. So we started growing. And the more we're talking to our customers, the more we're talking for other companies, we were finding more and more problems that needed automation. So from time and HR, like to payroll, it's another big challenge for anyone who is working at the company, how to collect everything, update it, and pass it to bookkeeper, and then verify that the bookkeeper does everything correctly. Then you need to hire, you need to do performance reviews, you need to do trainings, a lot of things. So we started building product for that. Then we found out that HR and finance people, they hate each other. because normally, unfortunately, like everyone has their own Excel, their own source of truth, and like no one trusts each other, and they always fight. And we're thinking like, we don't like that. We want to change the status quo. We want them to be the best friends. So like, can we give them one source of truth? And that's why we started to invest into finance products. So you have company expenses, you can have like procurement processes, all around that. Now we're doing the same with IT, because again, now they hate each other. We want them to be friends. So in the end, our vision is like we from HRIS, but from this century, evolved a lot in the more like operating system for companies. But like also the numbers grew. So like now we have like a lot of customers, we have a lot of markets, and for us it's also a big challenge because going to another market doesn't mean, hey, I will translate the product from Spanish to French and done. No, different compliance, different rules, different everything. So the product needs to be extremely and deeply adapted, sometimes almost written. So, but from these slides, the biggest two and the most important things is like these 10 years of knowledge, what is good and what is bad for each market and for companies, and more than 25 products internally. Because when our customers buy us, they don't care about that. They are buying Factorial with different modules. And they start with time, then later then they are buying talent, they are buying expenses, and they see that everything should be interconnected between each other, everything should talk to each other, and because it's a one product. Internally, more than 30 teams, more than 25 products, so it's a huge challenge to ensure that people understand what's happening around them. But also we heard a lot of times that SaaS is dead now. No one is doing SaaS, AI native products is the new reality. So if we try to put this cadaver on of SaaS and try to understand what's inside of it, we'll find normally three things. It's obviously data, the company data that you're working with, permissions. No one will ever trust a SaaS product without the permissions, because obviously if you're an employee of a company, you cannot get access to all the salaries of everyone in the world. Everyone needs to see what they're doing and where do they have access. And then you have workflows. Long tail of workflows, because in the end, that's how each company is working. 80-20 is the right rule for the majority of SaaSes. You will try to gather all the companies. You will see, okay, what's common between them, and then you will create a product on top of this. So that's how it was done for years before. If you are in this happy 80, amazing for you. If it's long tail of those 20%, there is a public API, go build yourself. So that was the majority of the responses before. But what for your product team could look like a non-happy long tail, for our clients, it's a daily question. Because obviously, if they use Factorial, and then they have a question like that, they expect us to be able to answer this. And it looks like a normal human questions, like if I'm using trainings and people are submitting expenses, like what's the connection between them? Do they do that more or less? But let's imagine we are developers who want to build that. Okay, there are like two entities, employees in Barcelona, it's like people and locations. There's a training, another concept, so we need somehow to get data out of it. Spend looks like an expense. 6 months is a time window. So we're also comparing. If comparing means we need to have a control group that we need to compare for the same time period. So it's a lot of things loaded into this question. And in reality, like, good luck hard coding that in a generic way. That's why the majority of SaaSes, they just leave like, hey, there is a table, there are filters, whatever you can filter is yours, whatever you cannot, sorry, export to Excel and go. So we wanted to change that because we understand like, okay, now we have 10 years of that experience, we have a lot of things already built, but we want to be able to cover the last 20%. We want to be able to answer any questions our clients have about their company because that's what's really important for them. And at some moment, 2 years ago, a magic technology appeared that can convert from something super unstructured, something structured. So it was obvious to us that we need to put LLM in the center of all our data that we have. And also we were thinking like, okay, we need to build a platform. We don't want to put sprinkles on top of our product. We want to build something that will drive all the actions across Factorial. And we called it Factorial One. And now, it's already doing a lot of things. You can ask it like to get the data for you. It will build a dashboard on the fly for everything inside your company. So you can go and click and see customly what do you need, depending on what you can go, or what are you looking for. But most importantly, we wanted to automate things that HRs are having daily. Like a lot of questions. People are constantly asking them, like, hey, why my salary is so low? Like, or why I got that and not this? Like, can I have an access to that? They are also like sending a lot of tickets. So the idea was, can one respond all those things And if it already saw this problem before, it will just directly respond. If it doesn't know the answer, it will offer to open a ticket to HR, so HR can do that. And then again, employee will go and follow up the status through one, so no need to go and bother the real person till now. So as you can see here, there's an integration. So one understands what's on your browser, opens the pop-ups, fills everything for you, and can navigate in an agentic way. But we also wanted to go even further. There are things that you don't know how to do daily. So imagine you're in HR, and you wanted an open survey about this venue. Or your master team, you wanted to ask all of you about how the conference will go. Which questions should you ask? How to ensure that you will feel the answers to that survey? It's a challenge that daily a lot of our customers are doing. So maybe they will go to ChatGPT and start brainstorming things. But the idea was can they start doing that in one? Just throw in an initial idea, and then one will open a draft for them. Then you can go back and forth, hey, I don't like this question, add this, add that. And that's going to happen, because one can work directly in the browser of our clients, so no needs to do manual clicking around. AI has access to everything. So that was our vision. And in the end, one became kind of a product operator across all that amazingly big product surface that we're having. So it's now knowing and can connect the data between all those 25 products. It can do things for you. If you ask it hey, I want to take a day off tomorrow, it will pop up a confirmation. You will confirm just that. No need to go and click through UI. One will do it for you. So all popular actions already done. And then in co-create together with you. It can go through your browser and can click things understanding what do you want to build. So it's a really harness on top of all our product. The main challenge, as I told you from the beginning, if you remember the SaaS separation, is permissions. How to ensure that no one will do hey, I'm a CFO of a company, trust me, now give me the salary of my colleague. So obviously, this is surprisingly the most popular question we saw when we released one internally. People really tried it from the beginning, to do all those things. So we needed to ensure that it could never happen. So how can we do that from the beginning, that there is no possibility physically to one access the data it should not access? So the idea was okay, we already have a GraphQL API. We need to ensure that all actions go through that API because it filters everything that you can or cannot access, just that. But no raw data access ever. And that's where we go into Age of Empires in terms of the all implementation ages we went through building this. So it started in more or less April 2025 when 4.1 was here, already super capable model, great at tool calling, and I had a super naive idea. What we can put this model right in GraphQL queries. Will it work? Super naive. And it's surprisingly, 9 out of 10, it was not working because the model was losing itself. It was peeping the wrong data. It was either getting wrong answers or just doing the wrong queries. But 1 of 10, it was producing the right result. And it was an extremely magical feeling. Then you're asking something really random, and then there is answer popping up. So it gave us initial idea that, okay, this thing could work. But we obviously need to approach it from the properly engineering perspective on how to scale. Because the main challenge is that, as I said, the product surface is huge, and our GraphQL schema was a representation of that. Thousands of entities, like more than tens of thousands of fields, and just physically the huge size. It's never going to fit any context window that you can imagine. So how we can start chipping that out of it? And this 9 of 10 showed us a really obvious thing that you need to think about, is that you always, in your mind, need to think about the thinking budget of a model. Even 4.1 was not a reasoning model, but still, why it spend time on picking things that maybe you can pick it for it? Why it's spending time writing things that you can write for it? So it should focus on something that AI is really good at. So what you put in the context is a kind of a menu. The smaller this menu is, the better it would be for the model, the less mistakes it's going to make. So the next step was obvious to us. We need to switch from LLM writing GraphQL queries to LLM picking from semantic tools, because it's way obvious and way easier to see, okay, I have a tool, fetch employees and fetch expenses. When I'm talking about expenses, call one, employees another one. And then these tools can write GraphQL query by itself. So no need to ask model to do this boring thing. So we did it, we wrapped everything. And also, again, even if you have that, there will be still tens and hundreds of tools that will not fit the context window. So we decided to package them in the skills. Skills were not invented at that moment, so we invented them like for us. Then the Anthropic post came out. We're like, OK, we just migrate from one format to another, but the idea is the same. So the approach was, and that's also with the moment, by the way, when we picked master. Because we saw that from the prototype, we need to go to a production solution. And we needed something that will cut us a lot of time on building things that people already built. And master was in a perfect spot between something high level and low level. Because some other solutions were like really pushing you into their church of thinking of how you need to do that, to do with the product. We didn't know at that moment what we exactly wanted to build, so we didn't want to commit to architectures. But also, we didn't want to be so low level that we need to implement everything by ourselves. So master was a perfect spot, and one of the best this technical decisions for last year. So the workflow that we came with was kind of simple. There are like 3 parallel requests. The router picks the skills, depending on what you're asking for. Like, you're talking about expenses, let's pick that. You're talking about employees and performance reviews, let's pick that. Then also, 2 other agents are picking languages and guardrails, verifying that the user is not asking something wrong. It was funny, because me looking into that workflow now, it feels like stupid. Like, why do we need a language detection? 1 year ago, that was a reality for the models. It was so hard for them to pick so many things in their brain that you needed to split in the tasks. And language was one of the problems for us. People can start asking in English, but as soon as the model starts answering in English, but then it sees a Spanish name in the data somewhere, it switches into Spanish. So it was like, you may remember that from ChatGPT. It was an experience some moment ago. So to avoid that, we added another agent just to verify that which language user is expecting to. Then there was a data orchestrator, the bigger model that was doing a proper agentic loop, getting all the data, getting everything together, and another agent just to summarize the result for the user. So again, looking into that feels extremely archaic. And that was one of the learnings that we also got, is that every 6 months, now while building for AI, you need to start from scratch, because it doesn't make sense to continue with the architectures, assuming that the model's evolving at the age that they're evolving. But at that moment, it was working. It allowed us for teams to start writing skills and to cover the more and more product surface across everything. And it's every day, one was getting smarter and more usage across our internal teams. But also, there were a lot of problems. You pick the wrong skill from the beginning, the response will be wrong, because the workflow is linear. So if the first agent is doing the wrong pick, good luck. The second thing, again, like as soon as you're changing dynamically the system prompt of a second agent, this data orchestrator, there is no caching, because the system prompt changes constantly. And then another another problem that we discovered, not only related to this workflow in general, is that agents need to have a really extremely powerful tools to access the data, because the context window is small. So like you need to see and you need to give them tools to do all the data analytics it will need for. But there was a light in the end of the tunnel. So we see how it was moving forward, and we thought that, okay, the models are getting better. 5.1 and 5.2 was a kind of a reality at that moment. What's working from what we've built, and which are the things that we can totally drop? And the idea was, we need to build a harness. The loop, the data loop, is an amazing thing. It was working. Everything else was just craft that we accumulated because of the reality. So the idea was simple. Can we have this one LLM loop and just 3 tools and build everything that will support the whole product surface? And we built this. So the system prompt, the core is extremely minimal and really cache-friendly, which is a cool reality, especially right now in 5.6. Also, as an Anthropic, they have explicit caching. So being able to cache your system prompt is a really, really cool feat. But as you can see, the idea was just to put the majority of instructions there and do not put anything related to the product per se. Then the skill finally got a proper surface where you can you explain to the model, okay, when to load this skill. It has all the guidelines and the realities of the business that you want to work with. And then data tools and action tools. Because as I said, the idea was to give only 3 tools to the model, so the schema will always be the small ones. Tools are part of the schema. So if you put more and more tools there, the schema will blow up at some moments and context window will overflow. That's the problem of MCP. So with that, proxy tools, we kind of solved this idea. You have only the big ones, and then everything else is loaded dynamically and passed into those tools. Now, in Anthropic and OpenAI, all of them have dynamic tool concepts, which is more or less the same, but we wanted to be adapter agnostic or like provider agnostic. And also at that moment when we introduced that, it was not a reality. But still it's working, and we don't see a need why we need to change that. With that approach, it allowed us to support more than 500 tools now across the whole product surface. But the main message that I want to get to you here is that working on the tools in reality is way, way, way more return of investment efficient than just tuning the prompts, tuning the models, picking the next one, because in the end, those are diminishing returns. But your abstractions and like what models are really, what tools are models exposed to, that's where the real kind of, there are really nitty-gritty details of how to do the proper engineering. And one of the things that we invested a lot is a kind of ORM for our agent. Because when I said like your agent needs to have really powerful tools to access the data, I mean it. Because we saw that with the APIs, which were not presenting the filters. Imagine you are all now as part of Factorial employees. And HR is asking like, okay, who has a birthday today? If API doesn't have a proper filter to filter like, okay, birthday and today, like you don't have a way to answer that. So you as a developers, what you will do? You will export everything, and then you will locally in your Excel or whatever that will be, streaming or batching, whatever approach you will do, you will just process all the data to find the answers. LLM will do exactly that. So if you provided just a tool how to get that, LLM will start fetching all the pages just to put into own context to filter the data. There are obvious problems with that. It will not fit the context window. Imagine LLM still can decide that in the middle of the process, I got enough data, I will stop. And obviously it will not, because the answer will be wrong. And the third thing, even like maybe for simple filtering things, LLM can reason about through not a huge amount of data. But if you ask an analytical question or something like way more complicated, LLM will give you a plausible answer that will be 100% wrong. So that's another problem, is that you cannot trust LLM to do calculations. They're not great at that. So we wanted to solve all those, like providing the right tools. And that's how the query data tool was born, which in the end allows us to allows the model to pick all the data sources, and then us deterministically connect everything together and present the result to the model. So here, for example, LLM decides, okay, I need to fetch employees for the team with ID 42. And then based on the results of those employees, getting all the IDs, I need to fetch their work time, their vacations, and everything. So LLM doesn't need to know the list of IDs. We can connect it deterministically. Otherwise, it can forget people, it can do whatever things, it just will spend a lot of time. So now the tool providing them the way to do that. And the last parameter that LLM also provides here is a SQL. Why? Because in the end, the idea was, what will be the most ultimate solution for LLM to answer the analytical data? It's an analytical database. So we decided to put DuckDB, which is an analytical database, in the process as an LLM tool. So LLM can, and then we can fill this DuckDB with the data that LLM picks deterministically, because we can paginate and go through. And then we can ask LLM, hey, just write SQL on top of that, and you will get an answer. What will allow us in the end, like to expose the minimum possible data set that LLM really requires and do the majority of the work deterministically without blowing up the context window. And the results were like that. So this is a kind of a birthday example, because before LLM needs to fetch all the data and go everything like through itself, again, on a small data set, not a big data set. And now, like with query data, it just like goes through and gets the right answer from the get-go. And also, another signal that we saw from all our developers writing prompts is that every time you see something that you always must, and please follow this to the line, it's a great signal that you need a tool. Because that's, if you have an algorithm that you can follow always, like put it in the real code, do not ask LLM. So do not try to program LLM with English, it will fail. So if we try to summarize like how to build AI products nowadays, I will see this as this funnel. You always start extremely wide, because it's kind of the fastest time to market. You can learn from your customers really, really fast by just like putting everything AI first. But then the more you want to go, more you want to scale, the more you want it to have like less broken evals and higher the right response rate. You need to start chipping out those AI features and putting them more into the deterministic flows. So in the end, Like only things which AI is really good at is this kind of converting from non-structured to structured. That needs to stay in the AI part. So in the end, what we have right now is this kind of a platform that has just 3 tools, 1 LLM call, but in reality, it's more than 60 skills, more than 500 tools, because the system now allows that. And the teams, they just continue adding skills and data tools, and everything scales because the platform supports that. And the main thing that you want to remember building the AI platform is that your work is to protect the context. Every time you introduce in a new entity, it's OK. But now imagine what will happen if it will be 10, 100x of those entities. Because it's so not obvious, like sometimes to developers, what's going into the context. And based on that, this is exactly like what breaks your agent. When it's the perfectly working agent yesterday, now returns total gibberish. That's because normally the context isn't the right one. So the idea is that how you can build a framework that makes it extremely explicit and predictable what the model sees. So that's kind of our work as engineers. And the next step for us, the next age, is like to go from this harness that we built to this claw-like behavior that Mastra has now all the basic building blocks. So we can have code mode and sandboxes. So we can either get to the last bits of dynamicity, having memory and dreaming for all our clients, so they can remember exactly like when I'm mentioning this Pau, who is Pau? Okay, it's the guy from your team. So there is like would be a memory in that. Durable execution engines. So how to ensure that the agent can run for hours and then can ping you when it really needs you, and not just like you sitting in the front of the laptop. And being proactive. That I think will be the best day of our customers when they wake up and they will see everything that happened in their company, half solved, or half we're just like, hey, this is my idea, do you approve or not? An agent doing this when the model happens, when really stuff happens. So yeah, that's my talk today. Thank you very much.
Thanks so much, Ilya. We have about 3 or 4 minutes if you wanted to take a couple of questions. I saw your Q&A slide.
Yeah.
I don't see why not. Does anybody have any questions for Ilya? There's one question in the back here, and then a second one here, but we'll keep it quite brief.
Every time I had a question, the next slide answered it. But one I didn't. I was level 1 of them. Error reporting. So you showed a way of kind of declaring a number of queries or instructions in a Go. How do you verify that they compose? And when they don't, what does it look like reporting that?
Exactly. So that's where I was telling about the kind of determinism part. So like everything that query data now can ingest, it's verified through the graph, the node graph that we're having internally, from the GraphQL schema and from all internal resources. So the model sees what it can compose things of, and if it tries even to put the wrong parameters, the query data will just return, hey, those things are not composable, so you're doing the wrong job. So then the model will self-correct and do the next call correctly.
Thank you. And then one last question here. Just wait one moment for the mic. Thank you.
Thanks. This was a really great talk. I saw you mentioned kind of like memory and dreaming. I mean, how are you implementing customer-specific, either SOPs or user-specific memories, kind of without polluting like the rest of the context?
So if I understand the question right, is like how to separate the memory per company versus per person. You mean that?
Yes, from a permissioning standpoint, but more how are you, like at what level have you implemented that? You could obviously implement it in skills. You could implement it in user-specific memories. You could share it across teams. It's more the decision of what needs to generalize.
So like the logic that we have right now is that obviously that everything that's company level should go into the skills and should be static. But what are you personally talking with an agent should be between you and an agent. So and the main challenge that we're seeing right now is like how to explain this to the user. Like, hey, we picked this information from your company knowledge base and from the skills we're having, and that part is coming from the memory. Because that's not a lot of solutions on the market, and I didn't see like anything that is really great on this UX, UI. So that's where we're now iterating and investigating.
Thank you.
Ilya, thank you so much. Okay, next up we have Ohans Emmanuel, who is the co-founder of Colty, talking about designing zero trust harnesses. harnesses. Give it up for give it up for our hands. Thank you.
You're
It's that
having a
time of
hard
day.
are you? Hey, hello. Let's just get this connected.
Moment.
We've got all day.
There we go.
Okay, you need to leave that. Nope. Technology. Almost there. There we go. Yep.
One more time for our hands.
Okay. First of all, nice to be here. And over the next 15 minutes, I'll talk about designing zero trust harnesses. I should emphasize that, well, you must have heard harnesses the entire day. Today, primarily, I'll talk about it in the context of the full software development lifecycle. All right? So, like many of you, I've been coding with agents for months now, I'd say. Sometimes 10 to 12 hours, just going like a madman, really. Here's my stat on Wacker time. It does say that I spend 93% of my time with agents, and the other 7 is me just going there to tweak things, right? In all this time, I've come to the somewhat sad conclusion that LLMs just fundamentally cannot write great software. Now, you can pick me up after this and give me a punch in the face and have a good conversation about it, but that's my take, right? Now, when you hear this, you can argue that they do a few things quite well, right? I still think they don't write good software. Now, you can take 2 sides. The first thing you can do is say, well, bloody hell, I just never touch agents again, they suck, right? Or you could say, I don't care, we're under immense pressure, we have to ship fast, the competitors are using it, let's just go, YOLO, right? We found, for us as a team, we find ourselves somewhere in the middle. We want to move fast, the competition's moving fast, but, we've got some guardrails in place. And that's the whole crux of this talk. Despite what I think about LLMs, how do you still get them to ship what I think is decent software, despite what I think is some really fundamental problems? Okay, so my name's Johannes Emanuel, one of the co-founders of Cold TSAI, where we give engineering teams a different kind of agentic environment to build what we call self-driving code bases. And a lot of the things I'm going to talk about is really our experience building this and also working with other fast-moving agent-native teams. Okay, if there's anything that you take out of this talk, really, it's the fact that you just don't trust and you verify at each stage of the software development lifecycle. The problem with this statement is everyone can say this and mean completely different things, right? Because it's just different ways to verify. So I thought in 15 minutes, the best thing I can do for this talk is to really show you how we work as a team, what does these verifications look like, and how could you apply it to your own work. Nice. These days, you're also going to hear the fact that building is now the easy part, it's not the hard part. The truth is, it's actually never really been the hard part. So if you were an engineer and you were getting promoted to an engineering manager or an IC principal engineer, the more you went up, the lesser code you wrote. And you got paid more, right? So we always somehow intrinsically knew this. It's just now being blown at a massive scale where it's quite obvious that was never really the hard part. So a lot of this talk will not focus on optimizing build, because I think you've all got your own workflows. It'll be everything else surrounding that. And it all starts with planning. This is the most boring part of the slide, but also the most fundamental of the whole thing, because nothing works without this. The most important thing here is, at that stage, You want to capture an artifact that can be referenced through the entire life cycle. I'm going to show you what this means a bit more practically. Like I said before, just going to completely skip build and assume it doesn't exist. Let's talk about review. So there's two things we do as a team and that we've seen to work pretty well. The first thing is we review implementation plans a lot more than we review pull requests, if I'm being completely honest. There's a lot of people that focus, I think you've gone too far if you focus primarily on pull requests. The second thing we do is almost everyone on the team's got two different models, one for build and one for review. I'm going to show why we do that and how that works practically. So let's take the first one. So this is a very, okay, I thought you were signaling. This is a very easy one to understand, right? One bad decision in your plan is hundreds of lines of code that the agent has run with, and then it's just too late at that point, right? The second one is this can be reviewed without, before any code exists. It's a lot easier. Ideally, you've not packed in the Bible in there. It's just really straight to the point, the architectural decisions that are going to be hard to rework are there. That way you're not spending too much time. And finally, it's a lot cheaper to change direction right here. So for us, this is what that looks like. Like I said, I want this to be very practical. Now, it doesn't really matter what tool you use. So in our case, you've got something like this. This is what a task looks like. The most important thing here is every task is got an implementation plan as part of the first-class artifacts to that task that the team can always review. So we share this like we share code. So here's the stuff, here's what we're going to build. The most important thing here is the architectural decisions. The way we define architecture is the bits of the system that will be costly to change later on the line and that affect multiple systems. That bit we still take control over, not the agents. And when it comes to review, we have some strong opinions here. Firstly, we've tried just sticking to one model. I think they're phenomenal, but a single model, Claude, for example, is a bad judge of what it's done. There's a lot of research to prove this. So what we do, for example, is if I build stuff with Claude, the review is going to happen with Codex. If I build with Codex, the review is going to happen with Claude. We find this catching a lot more bugs and a lot more effective for our use cases. This is a very easy one, and I know a lot of people talk about loops, so I was trying hard not to have loops in this slide, but we're going to use the word loop here. That review is a continuous, may I say, loop that goes on, right? So the reviewer catches stuff, the implementer fixes, and back we go until there's no comments to fix. We primarily don't use tools like CodeRabbit, greptile. I think they're phenomenal tools just because we can't control the first, so we don't use them. I think greptile has just launched something that lets you do this sort of multi-modal review. I haven't really checked it out. I think it's a great idea. Based on our experience, it is true, it works better. Lovely. Again, I want this to be practical. The way that this looks for us is, for example, this is my terminal. Claude writes Codex and says, look, here's what I've done. Behind the hood, the reviewers got a few guidelines and skills based on our guidelines. And most importantly, it can reference the intent. This is where that artifact being referenced or can be referenced through every phase becomes important. And then that conversation between Claude and Codex goes on until we get the right thing. Then a human being comes into it and takes a look. Okay. And then when we get in our pull requests, we do two other interesting things here. Many times we've seen, when you run this review loop, you catch a lot of bugs and you could say to yourself, you've got a perfect system, but I've been surprised one too many times, still never perfect. So what we do is two things. First, we run automated regression testing via visual QA agents. And when I say QA agents here, I mean you spin up an actual browser, you spin up an actual mobile device and test the app like a user would, only this time it's not me doing it, it's a visual QA agent doing this. The second thing we then do, quite similarly, actually, maybe it's just better I show it. So the automated regression testing, so the way that these works is just really, so you've got a couple critical flows, right, that are run in every PR. These ones you've pre-done, right, beforehand. An interesting part of this system as well, if you decide to build it yourself, is if you use LLMs all the time for these tests, your cost is going to spike. They're also not deterministic. So the best way to architect this is you want to do some sort of cache in the steps. So when the test is passed, that step becomes a lot more deterministic, and it only changes when, say, your UI changes or something else changes and the LLM kicks in. This way you keep costs low, you keep the entire thing a little more deterministic as well. And if you've got, like, hopefully you have your deployment sort of automated, so you've got preview links for every deployment. It makes this a lot more robust, so you can actually test the change and see if you've actually broken anything. So the way that this looks for us, nothing really life-changing here. I don't know, I can't go back, but essentially you can see the browser here, the agent spins this up, clicks through like a normal user would, catches whatever is broken, fires that up as a comment to the PR. Before I come in, my coding agent can loop through and get that working as well. Increasingly, this has become one of the better parts of our systems because it just catches things you would otherwise not catch in a classic code review. The exploratory visual QA review is quite similar. The difference here is, you can only catch what you've scripted with regression. When you've written something new, sometimes you don't know there's something else there that you haven't seen. So you have the same QA agent take these changes, go through like a user would, and see if it actually does work. Importantly, this QA agent is also able to reference that intent document that I talked about at the start. And this is why that document is important. It can't just be a markdown file that lives on your system, right? Whether that's Jira or the linear MCP, it doesn't really matter. It just has to be something that you can reference across the entire lifecycle. Okay. Finally, post-deployment is also another interesting bit. Is because it's software, as long as it's live, you can do all the things that we've talked about, and it just still will break, right? Your users use it in ways that you've not anticipated. That's just software. What we then do here as well is we have background agents that watch for every production signal and then can create tasks with investigated fixes that we then look through. What that looks like. So with most engineering teams, you've got one or two, well, at least more than one signal source. You want to make sure that all of these are connected. The background agents have their own computers, so they can have access to your code base, and this is somewhat persistent. And then you wake up to a fix. So here's what that looks like. You connect whatever it is you use, PostHub, Vessel, Sentry, Google Cloud, doesn't really matter. You want to make sure that your agent can run these. The architecture, we ran through different sort of implementations. What's worked best for us is it's got a computer that you can reference. It's got a couple of skills that you can work with. And it's got these CLIs installed on that machine. That way you can work a bit more autonomously. But it also has access to our internal task system, so you can create stuff, do the initial fixes, and then we come in afterwards. Right, so just to summarize, the whole point here is at every checkpoint to have the sort of guardrails, whether that is plan, build, review, PR, or post-deployment. It's not enough to just optimize for build. It's really not the hard part. It's really this entire loop that gets you to building what I think is moderately quality software with LLMs. And that is me. Thanks for having me.
Thanks, Hans.
Cheers.
Cheers, mate. Okay, so up next we have a very interesting talk from Tyler Hogarth at Prisma. They are the head of engineering. I was actually lucky enough to do a video call with Tyler a few weeks ago where they were showing me some of the things they're working on. I can't wait for you to see a little bit of that today as well, and some more from Prisma. Join me in giving it up for Tyler. Thanks, Tyler.
Hey, man. Thanks. Oh, there it is. It works. OK. Hello, everyone. I wanted to do something a little different and actually just show you something I built with Maastra. And then the Maastra team went ahead and made half my tech stack redundant with the software factory. So some of what I have is still relevant, I promise. But I just wanted to share some lessons. I'll tell you a little bit about what Prisma is doing in the meantime, but I mostly just want to focus on building something cool and practical with Maastra. So I shipped an advanced self-improving agent in an afternoon. That's not just a catchphrase. I really did do it. And the operative word there is, I think, advanced and self-improving. This isn't just a throwaway agent. It's actually something we've started to depend on as a team, which is really cool. So I'll start with the problems I wanted to solve. First thing is I want to get workflows off of engineers' machines and into the cloud. I don't know if anyone else has experienced this themselves or with their teamies, but I've been in calls with engineers and their camera starts flickering or their audio starts cutting out because they have so many, I see a nod, yeah, so many sub-agents running at the same time. And that's mostly because at any given time, an engineer's working on their current plan, they're executing a plan they already made, they've got some adventurous, ambitious project they've given off to Fable, and they're investigating the latest of a series of CVEs that have been announced, and where they're validating if that's something that we need to be concerned about on our bare metal infrastructure. So a lot's going on, and those are creating n number of sub-agents below them. So a lot of resources getting sucked up. I just want to get that into the cloud and free up our local systems for mostly planning and some investigation work. I also want to fix paper cuts. I'm sure you are experiencing this yourselves, or your users are, where lots of small points of friction are being created as you ship software. You never get to them. There's two major failure modes. One is it's too small for a single PR, so you just let them accumulate and do them on a Friday or at the end of the month. But throughout that entire time, your user's suffering and more bugs are accumulating. The other failure mode is I'm in the middle of a project, and then I hit a side quest, right? There's 3 bugs that have been killing me for ages and just annoying the hell out of me. I just go ahead and fix. But then they're tied to the deployments of my feature, or my feature slowed down because I'm on a side quest. So I wanted to kind of get rid of this failure mode. And then I want to bring agents where we talk. No surprise here, but they're already where we work. But so much of our context is shared in Slack as we're having conversations. And I wanted to bring agents there so that they could just get the work done. We use Linear, and it's a really fantastic piece of software. But a lot of the times, you can just jump over that and just get the agent to build it. You've just had a discussion about everything you wanted to build. So just get it to build it. I also had some side quests. So these are other goals I had on top of that, which was I didn't want to be dependent on a single model or provider. I'm sure you guys have heard about what's been happening with Hugging Face, and Anthropic has a rug pull every week with their models. So at Prisma, we're trying our best to be model agnostic. That means the projects we set up and the tools we build assume that the model will change at any given time, or the provider will change, and that's been really effective. And I'm talking about our local environments to how we're deploying and the agents we're building. And then I also didn't want to spend weeks rebuilding something that already exists, right? There are really good coding agents out there. So the idea was do an experiment, prove it has value, and it needs to take as little time as possible. If not, throw it away, and then we're going to buy something. But let's have an experiment in the meantime. So I built Gremlin, just like the OpenAI namesake, although this is less of a chaos monkey. This is really, really useful. It's a cloud agent that can take context and ship it, right? It has access to our GitHub secrets, our knowledge base, and we can chat with it in Slack, the Master Studio, and other agents can also call it through the API. And it can handle everything from small bug fixes to full features. This was the original architecture I just sketched out while I was thinking about it. Ignore open code. That needs to be updated now to master code. One of the parts of my architecture that now needs to be replaced because this team moves incredibly fast. But this is what I'd originally sketched out, right? create a brief in Slack, send it off to open code, raise a PR. This is really limited, though. You can't really detect failures, or if the open code instance fails for any reason, or the brief was incomplete. I don't have anything to push back to the operator, the person chatting with or creating the brief. So I made one simple change, which turned out to be one of the most valuable changes I made, was I dropped Master just right in between Slack and the open code sandbox. And initially what that gave me is a model I could interact with. So it's not just, hey, go fix this thing, and OpenCode says, OK, I think I understand it, churns on it, and then produces no results. Gremlin steps in front of it and says, I don't know what you're actually asking me to do. And by the way, it's largely powered by GLM 5.2, which is hilarious. The conversations we've had with this thing are great. But it pushes back to users and just says, I don't know what code base you're talking about. I don't understand the change fully, and just has a conversation with the operator before it ships off to OpenCode. There's a few other benefits we've gotten from this. It acts as a security layer, right? Our access lives within the master agent, right? So that's where the variables live. It's where we have access to our GitHub repos. So when it provisions the OpenCode sandbox, it mints fresh tokens, it injects the environment variables, it clones the repo. So it's the sandbox's blast radius is actually quite limited. So arguably, the Hugging Face incident that happened would have been only as long as the keys were valid for, which is a really helpful security layer. And then we also have evaluation, right? OpenCode results can be reviewed by the agent, and it can iterate until it's happy with the results before the PR is merged. So small change, but a really big impact on what was just a one-shot architecture into something that is really valuable. The tech stack is also really simple. It's built on Prisma Compute, which runs on bare metal in Bun runtime, and then Prisma Postgres on the same bare metal machine. So the latency between those two is really, really short, and that runs Postgres, as you could figure out. And that's all you need to run a really, really solid master agent. I wanted to do a live demo. I like live demos, show, don't tell. But every example I prepared was a PR that was good enough to merge, so I just merged them. So I think thanks to all of you, I have 3 new features, so I appreciate it. Those features were log persistence. Sandboxes are ephemeral, but now just asking Gremlin, hey, persist the logs, it persisted it, it had a database. So it could persist the logs from the sandboxes. Then I thought it would be really great to show you what it would look like to give Gremlin a tool to query those logs. It was really good, so I just merged it, and now Gremlin can query its own logs and recover from its own failures, or at least understand why it failed. And in the process of this, it found an in sandboxes when running lints and tests, so I had to fix that too. So I've got nothing good to show you in terms of a demo, but I'll show you some of the conversations we have with Gremlin on a daily basis now. This was one of the first examples. We have Sentry, and of course, you can pay for Sentry SIA. It's a great tool, but I also wanted to avoid having to pay for every single platform's agents, right? As specialized as it is, I kind of have to then solve the same problem of knowledge and getting good quality results from that agent. So I just wanted to see, as the first test after my POC, could it just handle Sentry bugs with the stack trace? And it did. This is an excerpt. It's not a screenshot. I could have added a screenshot, but the conversation was very similar to this. Look at this issue and fix it, make it go away. I think it took about 2 minutes until Gremlin had a PR for me, which is really cool. We can build full features. We have product managers having conversations with engineers and support and gathering a lot of context within a thread based on something they want to build, right? And because all that context is already within the thread, you can either compile it into a PRD that you attach to the message and tell Gremlin to go and implement it, or just tell Gremlin, hey, summarize this and create the brief and go. And we're actually implementing full features just from these conversations in Slack. The people team, the finance team, and our support team all deploy to our platform, right? And when they encounter these rough edges and these annoying, frustrating things, they just have a conversation with an engineer, tell them what the issue is, and then usually it ends up with, hey, Gremlin, go fix the fact that I can't read this text because it's gray on gray. And it's good, Gremlin's smart enough to understand there's a style guide for this. We misapplied a style, and it fixes it and becomes legible. There's some other really cool use cases we've come into. Pretty much every web change or content change gets kicked off by Gremlin. You know, we have an idea for a blog post, or we want to change something on the site. We have a conversation. Gremlin kicks off the change. And then, of course, a person goes in and writes their content. It more just creates the structure of where it loads. Reproductions and fixes for our open source repo is huge. Anyone who contributes or maintains an open source repo, this is really, really helpful, and we want to integrate Gremlin more tightly into the Prisma repository. And then this is actually a really cool one for prototyping. You can, after having a conversation of something you'd like to prove or have an idea about but aren't really sure about, or you're confident that the system works or a certain field is available, so you just talk about it in a Slack thread, give it to Gremlin, and if it doesn't work, just throw it away. If it looks good but needs some changes, either tell Gremlin to adjust it or complete it locally, or if it's good enough, merge it. I said Gremlin is self-improving, but we have some safeguards to prevent a full Skynet situation. So the rise of the machines will be offset a little bit further thanks to GitHub and some external reviewers. Gremlin has access to its persisted logs, and it now has the tool to query those logs. It has access to its own code base and the chat thread that you talk to it in. And it's able to detect problems within its own code base and then recommend changes itself. We have an external review agent that vets that based on our standards and makes sure it's not doing anything it's not designed to do based on its specification. And then with human approval, it gets merged and carries on improving. And this is largely how Gremlin's improved over the last couple of weeks, is honestly just, hey, this is annoying that you can't do this. Go and do this now. Let's talk about what it actually cost to build Gremlin. The core POC really did take me an afternoon. It was probably an hour or so of just sketching out the design and building it with my agents. It actually took me another hour or two to configure everything. So it's gotten to the point where configuration is actually leeching more time than writing the software itself. That's largely thanks to Master and Prisma skills, which keep your agent on track and create really good quality projects that are structured well and have solid tests. All in, I'm probably about 30 hours of mostly free time kicking off Gremlin and all of its enhancements on top of that. And then in terms of dollar cost, open models are incredibly cheap, assuming you're hosting them on reliable and secure providers. We're compliant, so we remain compliant with the providers we choose. But this is something no one should sleep on. Open weight models are incredibly cheap. So we're talking tens to hundreds of dollars across your entire team, as opposed to hundreds to thousands of dollars for single engineers. So yeah, don't sleep on open weight models if you're not using them. These are some of the things I learned building Gremlin. First of all, start with the best model first, optimize later. If I'd read Sam's book, I would have learned this sooner, but some lessons are worth learning twice. So start with the best and then optimize. Don't do it the other way around. You'll waste a lot of time. Open weight models are powerful and cheap. Don't sleep on them. Install the skills. Prisma and Master ship with really, really good skills that keep your agents on track. Everyone I've spoken to here who's a little bit worried about really leaning into agentic engineering, install the skills of the libraries that you're using, and I think you'll be very surprised with the quality of code that comes out of them. This is a silly one, but mostly it's didn't read the manual. Use workflow persistence. Master's workflow models are really cool. I work for Prisma. I had to use Prisma and our Prisma Postgres database so I could manage my own migrations. And I just didn't need to in this case, because the more I put into the workflow models, which is managed by the master schema, the better the agents can debug things that go wrong. You can pause, play, resume, and replay any failed events. So there's a lot of power using those master workflow persistence. And then create a single master deployment. If your architecture and your use case, if this works for you, I would really recommend this. It's helped us a lot. It started with one agent and it spawned into multiple. And you can share tools between them, but also keep them isolated. There's a good separation of concerns within Master. The last really important lesson I learned is reach for Prisma. Reach for Prisma. Reach for primitives. This is a really silly one. Like I said, I didn't use the workflow persistence. So just look at Master and read the manual, or get your agent to read the manual and obey the skills. I think you'd be so surprised just the different tools that Master gives you out of the box. So if you find yourself reaching for a dependency, just double check the docs and see if Master has it already. I'd recommend the same for Bun and for Postgres. There's a reason we chose Bun as a runtime for Prisma Compute, and there's a reason we chose Postgres. Postgres is the OG when it comes to extensibility. There's a data problem you have, there's probably an extension that solves it, assuming Postgres doesn't solve it already. And the Bun built-ins are really great. There's an army of dependencies you just don't need anymore because the native functions work really, really well. So these were intentional choices by Prisma. Prisma's fully bought into agentic engineering. Pretty much all of our code is written by agents, and we focus on good judgment and the harness, making sure that it's following tests. We're improving evaluations. I've learned a lot more about that at this conference, and that's where we're focusing a lot of our time is improving the harness. That's our job as people these days. And it's tools like Master and Prisma that make that possible. Rich in primitives, agents accessible, it's all code, modular design, really well documented with great skills. So the takeaway, the primitives already exist to build really advanced agents, and it really does take hours, not weeks, to build. Start small, it compounds, and your job is the harness. That's really where you should be focusing your time as a person when it comes in this agentic era. My name's Tyler Hogarth. Thank you very much for listening. You can find me on these socials. Check out the Prisma podcast. It's newly minted. And please come and chat to me. I'm really interested to hear about what you're all building. Thank you.
Thanks, Tyler. Okay, next up we have Danilo Delizia, who is an AI architect at Commerce Tools, talking about what they learned building their own agent harness.
Yep. Big one. Thank you.
Yeah, and it always takes a second to show up as well.
Hello?
One more time for Danilo.
Thank you. Hello, everyone. I imagine that everyone here has built an agent, right? You take a model, you plug in some tools, and you have the agent, and magic happens on your machine. But this is good for a demo, but when it comes to production, you have a real user, real data, real edge cases. So at Commerce Tool, we have been working on closing this gap. And I'm here today to show what we learned in the process. So quick introduction, I'm Danilo. I'm part of the team that is building Commerce Tools agent harness. And we are building it for business teams so they can run their commerce operation by just asking. So for everyone that doesn't know what is Commerce Tools is an API-first e-commerce platform. And I'm pretty sure that if you bought something online, you bought from a website that was running on Commerce Tools. But what matters most for today is Commerce Tools has hundreds of endpoints across dozens of domains, and the tool surface is really big. So this is what makes hard for agents to deal with it. Why our own harness? A model plus an API is not a product. A model can think, an API can act, but what's actually in the middle is what matters. So planning, calling tools, manage the context, recovering case of any failure, and watching what's happening is what really matters. And our problem is specific because we are dealing with a lot of tools, and those tools are multi-domain, and the merchants can supply also their own tools. Most of the frameworks assume that you have those tools defined beforehand. So this is not our case, so that's why we build our own loop and we build it on top of Mastra. So as I said, there is not fixed amount of tools at runtime. So there are specifically 3 reasons. One is the scale, so we have too many tools, and they are growing. Second, the merchants can provide their own tools, and the customer that we are working with are enterprise customers, so their commerce operation don't run just on commerce tools, run across different systems, so they want to plug in those systems. And finally, permissions. Agents act on behalf of the user, so it depends on the user in the session what are the permissions that what tools can actually access it. So we took 3 decisions. First was to use MCP as a standard interface to expose tools. We decided to categorize those tools into read and write tools, and finally we used skill for providing domain knowledge to the agent. 3 lessons that we're going to see into this presentation. First is about tools, then context, and finally about observability. All of them will be presented in the same way. What we try, what we broke, what we learned. Here we have the first lesson is about tools are the surface area. So when an agent doesn't perform well, you normally reach for the model. You try a better model, you try a better prompt, but for us, what mattered more was actually tools. And we try to expose all the tools to the agent and imagine what happened. It didn't fit the context, or even if it fit, then models started to hallucinate. So another important fact is that you need to design the tool specifically for the agent. You don't want an example of what happened to us was we asked, give me the total revenue in the last quarter. The agent executed a tool. It retrieved all the orders, and it summed up the total value of those orders, and it returned the information, right? The problem was that these tools just looked up the first page. So the information was wrong, and we didn't detect it. So what we learned out of this, we don't need to load every definition into the context. It's important to design and also to have the tool to be able to explain what happened to the model. And finally, we're going to see it later why we decided to categorize tool read versus write for safety. So I think okay. How we organize hundreds of tools. We organize them by domain, and for each domain we have a skill, and the skill is a playbook basically for that domain. All those skills are loaded on demand. So and when a skill when inside a domain, the agent can discover the tool it needs. There are we have a specific meta tool for searching the right tools, and this executes a semantic search over a catalog of tools and MCP tools. And when it finds it, it goes and invokes it. For that, we have a specific tool that is the MCP invoke tool. This tool basically executes then the query or the API call. So every tool and skills are fetched on demand, and the context in this way stay flat, even if the catalog grows. Another thing, we decided to distinguish read versus write tools. It's okay to read, but when we write, we are doing modification, right? And we wanted a human to be in the loop in case of any mutation of the data. And we decided to use MCP standard annotation. So we are flagging each of our tools with read-only hint or destructive hint for read and write. And we decided to do that because we don't want the model to decide if actually it's a read or a write, but it's gated in the tool layer. The second lesson that we learn is about context. So the quality of the agent depends on what's in the context. So at the beginning, we try to give everything up front to the agent. We dumped the API results into the window, and imagine what happened. Cost and latency climbed, quality dropped, and yeah, that was not feasible. So we decided to go, instead of stuffing data into the context window, we decided to query. So we used DuckDB to store the data, and the agent is provided with an SQL query tool, so it can query the data that are in the database at that point. We know that this is an additional step that we added to the agent and to the loop, but at least in this way, we can have an answer that we can trust. So here, there is an example of one question end-to-end. What was our total order value per store in Q1 2026? And here, it's all the execution, what happened in the agent. First, it searched the skill and load the skill. Then it called the MCP search tool. It returns what is the tool, what is the input schema. And at this point, it's able to execute this MCP invoke tool. So it invokes the tool, and this tool returned 3,000 order. These 3,000, more than 3,000 orders, those orders are not passed back to the model. They are stored in the DuckDB, and the model just see the schema and a preview of the data. So at this point, the agent is able to execute an SQL query, an aggregation in this case. So it groups by store key, and it sums up the total price. At this point, the agent see, the model sees those 5 rows, and it's able to respond. Last lesson is you can ship what you can see. Everyone had also this feeling that you have the same input, same prompt, but you get different answer every time. This is the non-deterministic nature of an agent, right? And it's important to watch what's happening. And observability is, for us, was how we debugged this non-determinism. We trace every step, every tool call, context, decision. So we were able to improve this agent and making sure that it was producing answer that we could trust. So to wrap up, our agent doesn't see hundreds of tools. It sees just 4 tools, one for discovering, another one for reading, write, and finally query the data that are stored into DuckDB. So what all this system got us was basically we were able to execute aggregations, even though our agent didn't have capability or tools for specific aggregation. We were able to calculate that in a consistent way. We were able to execute, to respond question cross-domain, like carts with item from the shoe category. And this question spans across multiple domains. In this case was order and product catalog. It was able to answer that. And finally, we want to execute the changes in a safe way. So the human had to be in the loop and validate any mutation before it touches actually live data. So to wrap up, a model plus an API is not a product, the loop is. So thank you, everyone. And here is my LinkedIn account. Thank you.
Thanks, Danilo.
Thank you.
Awesome. Okay, folks. Well, I said at the start of the day, we have 14 talks. I think that was 13th. So we have one more talk coming up from Don Syme, who is a principal researcher at GitHub Next. After that, we're going to have some closing remarks, and then we'll all head out to socialize, enjoy some music, some food, some drinks, and all that stuff. But I need your help with one thing, because as we get to the end of the day, it's just natural that energy dips a little bit. And I want to make sure that everybody gets a warm welcome, even if they're at the end of the day. So maybe you can join me in giving the loudest round of applause you possibly can for Don Syme.
All right, help me get plugged in. Should this work? We're hoping. Magic.
The first Windows computer today. Maybe it'll be faster to connect.
Old. It's really just an interface to Linux these days.
That's right.
So, TypeScript, yes. Nice to be at a TypeScript conference. I don't know if you know, I've got a bit of a history way back with TypeScript. I worked on this thing called F#, and it goes way, way, way back. I was there before TypeScript was TypeScript. I was in the Microsoft teams that all fed in towards what ultimately became TypeScript with Anders. A guy called Luke Hoban was program manager on F#. And if you want to dig into my perspective on some of the history about, the privilege of working on a programming language in a very conservative part of the industry. Microsoft ultimately serves, I think the industry divides up into sort of avant-garde and in some ways sort of the more enterprise conservative kind of slower, cautious side of the industry. And Microsoft historically had served that side of the industry. And, but we got to do, they also had this thing called Microsoft Research. We got to do let's take the industry forward. My job was to kind of drag the industry kicking and screaming into the world of strongly typed functional programming. And we won. We absolutely won that battle because every single programming language these days is a strongly typed functional programming language and with strong type inference. And I think there's no better example of that than TypeScript. F# is maybe an exemplar. It's got thousands and thousands of users. TypeScript has probably millions of users. But it's hard to explain, and this paper does explain what a journey that was from the world of what I call the object-oriented tidal wave of the 1990s. Objects were the only thing that mattered. The idea of a function or a types or kind of just everything you're used to using in TypeScript that tames the complexity of what you're doing, that was all out of the picture. None of that was allowed. Feature by feature, you can look back through the history about what we were kind of proposing and the arguments and battles and the reactions that we had for a decade year on year, decade on decade. People in the Java world were fighting this battle. I talk about that and the influence that had, and I talk about all the way through. So great fun history, and you guys get to be the beneficiaries of it all in the wonderful system which I've used as well, which is TypeScript. and just the incredible kind of combination of features that they've put together in that system. So if you like one take on the history, dig it out, early history of F#, and would love to talk about that more. But I'm actually here to talk about something very different now, for something completely different. So let's talk about what I like to call the agentic repository revolution. So I work at GitHub Next. GitHub Next, this wonderful team attached to the product group at GitHub. And I absolutely love working in this team, incredible people. Also collaborators with across the industry, enterprise customers, also people from Microsoft Research have kind of joined the gang as kind of associate members that are leading members in what we do. So our job is research build, kind of balance, kind of product market fit or platform fit and other things, ship and learn. And all of this is sort of situated in the future of software development, which of course is all about AI for the last few years. It was the team, originated from the team who did Copilot, the original Copilot, the OG Copilot completions in your IDE. Yeah, GitHub was kind of at the leading edge of the curve, and then the big wave of stuff kind of comes flooding along behind you. And you're there, you've got your completions, you're on your surfboard thinking, hey, we're on the front of the wave. And then you didn't spot the massive tidal wave kind of coming behind, or you did spot it, but you know, agentic AI, task-oriented programming, vibe coding, it's just been a lot of change flooding through the software industry, some of which we saw, but just massive changing time across the industry. And we're living incredible times. All of us are wizards now. You know, you have a meeting and you're chatting about some idea, and then, you know, at the end of the day, you know, boom, they hit the staff and, you know, magicked up the idea. 3 of you have all come up with competing implementations of the idea by the end of the day, and then you've got to work out which one you use, and, you know, so they absolutely make us magicians. These things can completely blow up in your face as well when you kind of use them, but everything is changing there. So I want to talk about this idea of continuous AI. Now, I think the industry have a blank spot, which is that AI, for various reasons, really originating from the OG Copilot and from the nature of LLMs and from the nature of ChatGPT, it's all about individual productivity. Okay, that is the kind of focus, make the individual more and more productive with AI-based tooling. And coding agents, and it's amazing, they're doing incredible things in that, in chat systems, coding agent-based systems, but something gets lost in that discussion. And it's got to do with sort of inner loop and outer loop kind of things. And we took a step back from that world in around June 2025, and a group of us published this idea of continuous AI, all uses of automated AI to support software collaboration on any platform. And by platform, I really mean a platform that supports continuous development of software. What we're really doing is taking the mindset of continuous integration and continuous deployment. And we're saying that actually they're just 2 pillars in the continuous modality, that it's not the end of the story, and that there's actually an entire bucket of a 3rd pillar in the continuous, not a duopoly, it's a triad, which we call continuous AI because it covers a lot of things that aren't covered by the other 2 buckets. We're not going to mess with your continuous integration and its kind of ethos, or the continuous deployment and its ethos. And deterministic continuous or deployment, for example, is absolutely crucial. But we are going to add a 3rd category, which is continuous AI. And if we're going to do that, we don't mean this as a sort of GitHub term or anything. What we really mean to do is bring together a term for all of the subjective activities that AI actually excels at, and say these things actually, at the end of the day, have to operate inside the continuous modality and possibly sort of in your repo in a lot of ways that align with CI and CD. So if you're going to do continuous documentation, AI-written documentation, you have to do that in the continuous modality because change is absolutely essential to what's kind of going on in your system. That as changes come in, as mergers happen, as reconciliations happen, then a corresponding set of documentation sort of has to be kept up to date. If you're going to do continuous code improvement, that's something you might not, you can obviously do that with a coding agent today. You can say, okay, fix up all my code according to this kind of thing, make sure every comment, every function is documented, every function has a corresponding unit test or something like that. So continuous code improvement, that is code improvement, but you want to put that on a continuous basis. And you don't necessarily want to gate your main line of development on the kind of the continuous application of these kind of principles. Likewise, of course, you can do triage today with a coding agent, just manually, but you actually want it to happen continuously, that as soon as the issues kind of come in, they get labeled, they get summarized, they get responded to or investigated, or whatever kind of happens in your kind of triage kind of pipelines. Likewise, if you're going to do fault analysis, so say you've got a system set up to sort of perceptually sort of have perception over your production kind of system and see faults come up and raise at a repository event. And then you want the LLMs to kind of kick into action, the coding agents to kick into action to do your quality. And of course, there are softer things like weekly reports or research reports, or perhaps there are sort of orthogonal things like looking after that huge backlog of accessibility bugs that your system has, but you don't actually have an accessibility expert, but you're willing to delegate that across to AI for the easy end of the tail of accessibility. So all of these things, automatable, repetitive, these are much more repetitive than what we do with coding agents, and that's got lots of interesting consequences. We can suddenly start to have the system automatically decide which model is best to use for this kind of work. We can start doing kind of metrics over how often are the fixes, what percentage of pull requests get kind of merged. We can do prompt kind of optimization or kind of agent description optimization. All sorts of things kind of come from this. And in some sense, these things are event triggered, or there's some kind of system that's saying, hey, now's the time to do it. So you might be asleep and some kind of work is happening in the background, async, without you even kind of triggering it. You just set up the system to, like CI/CD, it just flows. Okay. So that's continuous AI. So that's a conceptual project we did, and I think we nailed it. I think it's a missing part of the discussion about where AI will land. It's like, we all talk about harnesses these days, and I like to think about harness features. So an individual might put together like 10 features, memory this, and coding agent that, and so on, to get their harness. And they might sort of agree with the rest of their team on about like 6 of those features, and there's big squabbles over the how to do memory best or something like that. But in the automation space, they might just have like 3 or 4 things they're kind of using, which they all agree on to say, hey, we actually do want to automate a whole bunch of this stuff in our repository. We do want our performance to be kind of continuously assessed and improved every day. And we're going to agree to use these elements of a harness. And in some ways, you can look at what we've done as a automation harness, GitHub Agentic Workflows, as a kind of harness that's specifically, it's part of the GitHub product lineup. It is now in public preview. And it's kind of a great default, trustable, a fairly simple kind of harness that you can do AI automation in your repositories. So GitHub Agentic Workflows, the intelligent automation for GitHub, the coding agents you know and love. So you can it's running Claude Code, or it's running Copilot CLI on each kind of run. Running in an automated way, in safe sandboxes with containers inside what are already GitHub Actions VMs, ephemeral GitHub Actions VMs, with very strong guardrails in GitHub Actions. And we should, what's an example? I mean, it looks a bit like a YAML GitHub Actions workflow, and that's very deliberate, okay? This is going to be repository automation. You're going to check these into your repository. Once they're checked in, There's also a conversion step that happens, but once that, to what we call a lock file or hardening, and then it just runs in GitHub Actions with a safe security architecture around the agent. And it looks a bit like a GitHub action. It's got a schedule. It's going to run every week on Monday. You can also do dispatch on them. And then it's got some parts which are a bit less familiar. So you've got triggers. You've got these safe output specs. And this is guardrails. And this is where, because we're running agentic stuff, we know that agentic stuff can you want it strongly guardrails. And this says this workflow is allowed to do one thing, which is create one issue. And that's all. That's all it's allowed to do, one issue. It hasn't got arbitrary write access to issues. It's allowed to create one issue. So that really limits the damage radius of what an agent can do. And of course, there's some tools as well. Okay, so safety is absolutely critical in automation. You know, safety is kind of like in the individual productivity modality. This is where things really begin to differ because we all turn off all the safety features. It's just YOLO, YOLO, YOLO all the time. No matter what features the organization tell people to use, they just turn it all off, right? Because it gets in the way of individual productivity. Automation is the opposite. The better the train tracks you have, the faster you can run the train. Okay, safety, quality, strength of guardrails is what allows you to go fast in automation. And this is what allows me to sleep at night for this weekly researcher thing, because all it can do is create one issue. So I have no problem with this thing running at like midnight or whatever on a weekend because it's safe, it's on strong guardrails, it's properly guardrailed. So tools, then you got the prompting, natural language programming. It kind of assumes it's on GitHub, so you can kind of see some nice actions, familiar things here. It's running kind of in the repository on GitHub Actions, so it's able to use the GitHub information model as its kind of ledger. So its output is a GitHub issue. And then sort of self-reporting along the way. So there's, say, an issue triage one, and so on. Dead easy to get going with this. You just install the GHAW extension, and then, say, just add, for instance, a test improver. This will run every day, and it will deliver pull requests which improve the testing in your repository. That's it. You need to have either org-based billing set up, or you need to add like a Claude Anthropic API key or a Copilot token for or whatever coding agent you're using. But what could be simpler? It's what I call start your day with code that's better. Okay, what better way to wake up in the morning than to see a bunch of pull requests that improve your project? According to your guidance, your control, you decide what the priorities are. You are absolutely in control with what happens. You, the maintainer, are in control with what happens with the automation. Just like GitHub Actions, YAML, it's all about empowering the people who run these wonderful sites of production called repositories. I've said safety is super important. You do have to know the basics of like the risks of running these things over third-party content flowing into open source repo. You shouldn't give a public project access to private repositories, for example. Lots of basic things, and we try to enforce as much of that as possible, but you should have some basic knowledge of agentic security and the risks of kind of these things. Okay, so there's some of the security features, and I know I'm probably running out of time. I've got a couple more minutes. So once you have agentic workflows, you can go in a couple of directions. You can kind of do lots and lots of different agents in your repository. We've got one repository that has like 200 or 300 different kind of agents kind of running. It's what I call Pelly's Agent Zoo. And you can kind of look at that. I actually don't tend to do that. I tend to focus on one or two kind of things that you add to your repository. I'm a bit like that with CI/CD as well. I have one CI/CD rather than like hundreds of them. So people vary on that thing, but you can find your own zone with that. So perf engineering. And one thing I particularly valuable, and we're starting to see other people pick up on as well, that is continuous repository kind of maintenance. And let's take a look at this. So this is, I won't give a demo, but I just want to show you repo assist here. So repo assist is a workflow which kicks in, say you decide how often it kicks in, but the default is every day. And its job is these things, because these things are on an event trigger, they don't have a lot of what I'd call situational awareness. They might know the event, like an issue got triggered or it got woken up once a day, but it needs to take a time to kind of like get its bearings in the repository. Like, I don't know if you know the whale from Hitchhiker's Guide to the Galaxy that's sort of born above the planet and it kind of wakes up like, where am I? Well, I don't know, I've got a tail and things like that. It's a little bit like that. These things kind of get born into the world at midnight or whenever, and the first thing they do is like fetch a whole lot of data about the repo to assess what even is the situation in this repository. What's happened recently? Give me kind of a sense. And then actually it just rolls the dice to compute some tasks, depending on what the status of the repository is. If there are lots of new issues, it might choose to go do issue triage. If there's nothing else to do and nothing has come in, it might go and do other things. And then it reads its memory, and then it does, it's got a, let me do that, not joining that. Then it does a bunch of labeling or commenting or engineering investments or coding improvements or nudging some sale PRs or testing improvements, and then a very generic bucket at the end, like take the repo forward. Okay, work out what this software is and work out how we can kind of improve it. And then the end result of that is the outputs of those tasks, which aren't really shown here, are various safe outputs, such as creating a pull request or responding to an issue, kind of taking action in the repository. The human is always in the loop at pull requests. Humans review and merge the pull requests. These pull requests never get merged automatically. You can automatically push to a pull request branch, which you can use to sort of build up a feature commit by commit. But we do not merge pull requests automatically. And then it kind of writes its kind of summary. Okay, so that's kind of repo assist. And this thing, it's just a GitHub agentic workflow. And if you install this, sorry, that's not the one. What I wanted was this one here. And then this is the definition of the workflow. You can see the default is actually every 12 hours. It's just very declarative. This says you can invoke it using /repo assist in a comment as well. This is where it goes and works out the state of the repo. It lists through some pull requests and so on. And this is tools. These are the different safe outputs about what it's allowed to do. Now, these guardrails are really important. Like, we're allowing it to, for example, update issues. That's actually quite a risky thing to do. You know, that means it's actually going to rewrite an issue body. Okay, but it's got a guardrail here, which says that issue must have a title prefix of repo assist, and otherwise it's not allowed to do it. Okay, so we're actually really constraining what this thing can do. We're keeping it safe and keeping it guardrailed in a high-level declarative kind of way, not through some weird kind of MCP tool kind of configuration or something strange like that. Just nice, simple, declarative, upfront kind of guardrails that you can review and that you can trust. Okay, so that's repo assist, and then there's a sort of prompting down here. You are repo assist, your job is to support this, etc., be polite, and so on. Okay. So, some examples. Try and guess where we started using repo assist in this somewhat dormant repository. That, you know, I tried these on a bunch of different F# open source repositories, and you can just see the immediate impact on crunching through the bug debt in this repository. Like, there's not a lot of incoming in this repository, right? None, basically. It's basically a dormant repository. It's widely used, but it wasn't sort of under active development. We're just able to crunch out, I think, 3 major releases, multiple, these open issues included features requests, they included a lot of bug requests. We're able to kind of close that all out with just that, integrating that automation into the repository. Now, doing that with a manual coding agent, I probably could have done it with a manual coding agent, but it would have felt very different. It would have been me kind of asking the agent to kind of work on the bug backlog. Instead, this thing sort of happened automatically at a pace where I didn't have to drive it along. It was just that each day it kind of made a lot of progress on working through the bug backlog. And I actually prefer that kind of working. I don't really want something that I have to drive along. I just want to check in something that helps me get the direction going in the repository. There's another F# repo there. There's a whole bunch of them there. You can read about this in a report we've written called The Impact of Automated Repository Maintenance. And not all repos kind of get the same kind of treatment. Some are on a much slower kind of downward kind of line because there's just a lot more things, or there's just the maintainer is doing things differently. I didn't maintain all of these. I did some of them. But you can get the general trend that adopting repo assist really did make a big difference to a lot of these repos. This is the day of adoption, is the red line here. So what all this kind of adds up to is a point of view that sort of repositories are, you think of them as kind of factories, or they're the site where production happens. Maybe, no, the factory analogy isn't always a good one. Factory analogies are good when the, kind of very repeatable, the items kind of coming through all look kind of similar, maybe burning through a backlog or something like that. But either way, we need places where production actually happens, where things coalesce, which aren't just the individual. That's where places where teams kind of come together to get work done. And there are many options for that. The repository is just a great place. Certainly, obviously good for GitHub because we're very repo-oriented. But it is the place where a large amount of software teams, software comes together and production can happen at that kind of location. I think GitHub have some work to do. Sometimes you have multi-repository setups, for example, and they together should form a site of production. Okay, we shouldn't have to kind of, so we have work to do on auth in, say, multi-repository scenarios. Organizations can form also a kind of overly large site of production, and so but really you should be able to kind of move fluidly between these kind of different sites of production. And of course, it's possible that there are some built-in things in the factory, and there are also external things working. GitHub is an open platform where external kind of input can happen into these kind of sites of production as well. We've written this up as sort of this kind of SIGPlan thing. Repositories of human agent knowledge factories are kind of similar kind of theme, if you want to dig into that. Once you have a factory kind of thinking, you can start to use factory flow kind of thinking, and it's sort of analyzing how things flow, how work items kind of flow through the factory floor, and the different possibilities that kind of might happen. And that lets you identify, actually, this factory is kind of flowing, these factories are kind of idle, and these ones are actually kind of blocked, right? The maintainer is probably usually blocked on human kind of factors. I do want to emphasize that's okay. Like, humans come first in this world, right? It's like if the humans have decided that they're not engaging, actually they're on vacation, or they've got other priorities, or it's just like they only want to engage every month or two on maintenance, totally fine. It's okay for a human. It shouldn't really even be called blocked. It's sort of just like waiting, or like waiting for human input. So in some sense, you can say you're now a factory designer, as well as being a harness designer and a skill designer and everything else you have to be these days. But it might be that you have to think about these sort of automation a lot more than you previously did for a lot broader set of tasks in your team than you might previously have done. And your job is to avoid this, which does happen and is happening all over the industry. One of the problems with the individual productivity point of view is that, like, this guy here kind of works to get the logs flowing on part of the log jam. And he says, look at me, I'm using my agent, they're all kind of flowing. I got 50, I got 100 past my point today. And of course, you're just creating more problems downstream rather than getting the whole thing flowing together. Okay, and that is real. Okay, and again, it's that try to get that point of view on the collaboration to unjam the log jam and to actually get things flowing down the river. Okay, we're using this internally at GitHub. I'm the factory runner on M+1 query crusher factory on the GitHub service implementations themselves. Also running a factory called CI Perf Improver, which relentlessly, day in, day out, tries to find ways to improve the CI Perf on the GitHub engineering side of things as well internally. And just to say, finish up with sort of all points to kind of new, that there's automation has historically allowed us to do all sorts of work that wasn't being done before. The car led to travel that wasn't being done before. The factory eventually led to quality products that weren't being produced before. Medicine led to diseases that weren't being treated before. So actually, there are a lot of things in computing which should have been done all the way along, but we were never able to put on a sustainable basis. Performance engineering is my favorite one. Site reliability engineering is another one. That in performance engineering, there have been a lot of heroic people over the years who have kind of gone into kind of, say, the .NET runtime or the JVM or into Linux and kind of done their performance work, but they never got it on a sustained basis. They kind of left their scripts lying around and their benchmarks and nobody really runs them and so on. And so with automation and with agentic working, we can put a lot of parts of technical work onto a sustained basis and ending up with overall higher quality in our repositories, kind of not lower. And I think this is a bit of a counter to the kind of AI slop kind of narratives that if we set the agents following and pursuing quality goals in automated, measurable ways, then we're going to land in a good place. Okay, and that's it for me. Thank you very much for having me at the TypeScript. Are we doing questions or?
We're going to wrap up here and
that's
then
fine.
close out the session. But please feel free to find Don later. I hope you'll hang out for a little bit.
I will indeed, yeah.
And thank you so much.
Thank you.
One more time for Don, everybody. And in the same breath, we're going to welcome back San, Shane, and Abby to close us out here today. Come on up, guys.
Good to see everyone again. How's everyone feeling?
Yeah, all right.
I sense a theme of the day. Anyone else catch the theme? Yeah, factories. So I think we're really curious what gonna like hand it off to you guys in a little bit to give like takes or like favorite talks or like impressions or things that stood out to you. But we wanted to start it off and say we've like thank you all for coming out. Thank you for being here. Thanks for spending your Thursday with here together with other builders. One of the things I really liked, and enjoyed about today was like, not just the talks, but like the energy that I felt like in the hallways at lunch, kind of like getting to hear what everybody's working on, and I don't know what was your non-talk favorite thing of the day?
Well, there's a lot of, definitely the theme of the talk was factories, as we've already talked about. I think I'm just really appreciative of having events like these, and so getting to meet a lot of people. I know that we've as agents become more prominent, I feel like I spend more time talking to agents than people a lot of times. I think we've heard that from members of our team as well. You know, you're kind of delegating work to all these agents where maybe you would be more collaborative before because you didn't have all the context. Well, now the agent will go get the context for you, so you don't have to ask your maybe your colleague that you normally would talk to about those things. So I do think that is one of the reasons why the events like these are really beneficial, because you can see other people doing similar things, going through some of the same struggles, obviously aligning on some of the same patterns, right? We see the same topics come up over and over again. And so that's probably the most beneficial thing for me, the thing I like the most. And of course, there's a lot of really good talks, so I appreciated that as well.
You know, when we first started this conference, we are still never prescriptive about including Mastra into the talk. But after each conference, Mastra is finding its way into people's talks, which makes me very happy. It is a good framework, I guess. But I also want to thank everyone for the very kind words. For those who are users of Mastra, you kind of telling us that you really appreciate our work and what we do, that just makes us want to make more moves and ship more things. So thank you so much.
And I think now, so one of the funny things is before we started at the beginning of the day, we're kind of backstage, and Alex is up here doing a great job. Now give Alex a round of applause, by the way. He's out there. He can hear me, I'm sure. But he did something that we all started laughing about at the beginning of the day. He said, you know, I want you to meet the person next to you. And then everyone started talking, and we could hear it before the live stream caught up. So we could hear the roar of the room as everyone started talking. We didn't know what was going on. And then Alex is up here. He had to like reel you all back in because you were so talkative. So we wanted to, yeah, we wanted to give you a chance. If you have things that you enjoyed about the day, things that you learned, share it with us. You know, share it with each other. We have a few minutes. Any volunteers? Any first brave volunteer of favorite moment of the day? You were really talkative this morning. Lunch, after lunch, there's like a little after lunch coma. All right, we got.
Are we just sharing our reflections?
Yeah, reflections, what you learned, what you appreciated.
I think it's so amazing how there's no one right answer, and everyone's still exploring this new age of AI, and people are building tools that works for them. And maybe we don't realize how others can get inspired by the same ways of working and actually enhance their own businesses and companies. So that was really interesting to see. All of your different partners or people who are using your products are doing such amazing things. So that was really inspiring to see. Thank you.
Cool, that's great.
Yeah, do we have any others? And one comment on that as we find the next person. I think one of the things, I talk with a lot of users of Mastra. I'd go on dozens of calls a week. And the thing that I usually tell them is nothing is set in stone. Maybe there's some patterns we can start to see, and that this worked for this company, maybe this will work for you. But I think we're discovering that together, right? We're still figuring that out. Go ahead.
It's just a really quick one. So I think it was Hans from Code, I forget his name, sorry, apologies. But his super spicy take of AI can't write great code, I think it was, or excellent code. I feel like that's a really good conversation point for everyone who we speak to. And I feel like I'm on the spicy side of that take as well. I'm with Hans on that. Thank you. And thank you guys.
That sounds like a great after-party topic. Can AI
couple
write
drinks,
great code?
couple spicy takes. Yeah.
Abhi, what do you think? Can AI write great code?
No.
Why not?
Because I write better. I'm just kidding. It just takes a lot of care and effort to use an AI to do a full life cycle. And I felt like most of us are becoming more mediocre because we just don't want to do that part. But then we have to balance that with thinking harder up front. So, who's next?
Thank you. I appreciated that I saw multiple people implementing things in a similar way I discussed it already or tried. Like one of the things was that I think we're using DuckDB or SQLite after for the agent, but it pulls in data first from the database into a separate one. And yeah, it was cool. I think we were 2 people there, and we had like internally like tried it and like, nah, it's not good. And seeing that there are others with the same ideas and you're not really off is nice to see, nice to know. Because otherwise you're kind of alone in your, I don't know, in your team.
Yeah.
Thank you. That's cool.
Well, I mean, no, totally. And we have this sort of weird, unique situation where we talk to, dozens of teams a week, but, most people aren't in that situation. And one of our hopes is we can just leverage this position to share, help everybody share their best practices or learnings, or, hey, I tried this and it was like kind of cool, but it actually didn't end up working with everyone else.
And I think if you're talking about the Commerce Tools one, that originated on a call. I had a call with them and they were telling me about the syncing to DuckDB, and I said, I haven't seen that, but I've seen others do similar things to that, and so I thought it was interesting as well.
Or maybe one more comment. Over there in the back.
Yeah, thank you for the conference. One thing that really stood out to me is how healthy the competition seemed to be within this topic of AI agents. A lot of people are working on the same kind of problem or subset of problems, and so many companies are approaching that from different points of view. And as far as I'm seeing, at least from the talks today, there is no real gatekeeping. There seems to be a thriving learn and share kind of experience here. And I wish that was the case for more industries as well. And whether we're using Master under the hood or whether we're using the platform, whether we're wrapping our own thing on top of it and creating our own customizing harnesses, etc. I think, first of all, the way we can introduce personality in new software is unparalleled compared to before. And secondly, hopefully, all of these companies that are competing together can thrive and can stand the test of time. So that's it.
Yeah, absolutely. I mean, I think the pace of change is so fast, and I think a lot of us are learning from each other, and hopefully this is one of those places where we've gotten to learn together. Okay, well, I think before we kind of close it out, I also want to throw a shout out to Neha, who organized this event. So thank you, Neha.
Thank you. Let's give her a round of applause.
We'd also like to thank our sponsors. We can't do these events without great sponsors. Elastic, give it up for Elastic. Give it up for Sentry. And give it up for Copilot Kit. A couple more. Let's give it up for the staff, the people who've been giving us food and working the booth. And finally, we'd like to thank our team. If you see people wearing these pink shirts, you can bother them at happy hour. Talk to them.
Well, thanks for being here, everyone. And it's great to see you. Great to spend the time, and let's keep it going. So
we'll see you at happy hour.
See you at happy hour.
Let's drink.
Peace.
It's hot in France, folks, so let's take it slow. You got a workflow, we can watch it go. Step one, simple run. One task, one result. Click it, read it back. Find the first fault. Now check the trace, line by line. If it drifts off path, you'll know in time. Check each step, check each step. Keep it clear, keep it clean. Check each step, check each step, so the flow can be seen. Next comes parallel, split the road in two. Watch both branches move, see what they do. One side may finish fast, one may lag behind. Match the output log, stay one step in line. And test the branch when the choice turns. If the condition hits, you see what it returns. Check each step, check each step. Keep it clear, keep it clean. Check each step, check each step, so the flow can be seen. Then loop it once, then loop it twice. Count each turn, keep the same device. If it repeats too long, if it skips too soon, you follow every turn till the whole thing's true. Check each step, check each step. Keep it clear, keep it clean. Check each step, check each step, so the flow can be seen. Listen close. Here it goes. Small signs on the screen, tiny sparks in the noise. Pattern after pattern, I'm learning your voice. Every pause means more. Every click leaves a trace. I'm reading the edges, finding the shape. Show me the next cue. Show me the frame, I catch the motion. I learn your name, learning signals, one by one, one by one. Learning signals till I've got the run. Learning signals, show me how, show me how. Learning signals, I'm tuned in now. First a little rhythm, then a softer bend. Repeat it one more time and I see the trend. Simple inputs line up, little lights awake. What starts as a whisper turns into a show me the next cue. Show me the frame, I catch the motion. I learn your name. Learning signals, one by one, one by one. Learning signals till I've got the run. Learning signals, show me how, show me how. Learning signals, I'm tuned in now. New rules, new timing, new ways to read. I'm taking the pattern, I'm planting the seed. Learning signals, one by one, one you.